Dun dun dun! Building a custom designed powered MULT Part 2. Welcome YouTubers. Let's get YouTube chat up. Auto find und activate. Only ended YouTube stream. Try again. Try again. Try again. Ugh. It's not. I gotta wait for YouTube to propagate properly. Propagating. Propagate. Why you have trouble with this? Why are you having trouble with this? 12 minutes and 19 seconds until it tries again. Try right now. You son of... Okay, well, YouTube chat will eventually integrate into all of this. I love how Twitch tried to police that and like people got banned for having multi-chats. And they were like, you can have multi-chats, but they gotta be super separate from one another on different sides of the screen, and they need to look a particular way. The reason they made those rules is because their most popular streamers were just doing that. You have to be like Hassan. You can only do it that way because you're going to diminish the experience of... And then they lineaged back again and again until they were just like, it's fine. Like, it's like, come on. What are you doing? All right, let's try. Let's try now. Don't you... Well, it says my quality is excellent on YouTube. I should be, I mean, hold on. Let's test. Bonk. Yeah, the chat's running. Let's try again now that there's a chat in there. Still? What are you doing? What are we doing? What are we doing? Social Stream Ninja, you are confused. You're going to harm yourself in your confusion. It's right here. There it is. That's the stream. Weird. Well, whenever that decides to do its own thing and comes back to us. Look at this McDonald's Happy Meal looking crap. We got red and yellow on the first one. On the test one, I decided to get red PCB this time. I don't know why. Blue might have been a little better. I don't know. Red is a weird color. But you're not going to see that. You're going to see the front panel, which I did not design in CAD. Well, I did actually, but it's like an add-on. It's a 3D printed panel. I don't know if I'll do. I don't think I want to do a PCB panel for this one, although I could have. Actually, the PCB panel would cost me more because it's over 100 millimeters. This is the maximum width you can do for the low-cost boards, and I guess I could have also put more designs horizontally to get that 100 by 100 millimeter limit, but I didn't push. You have to declare different designs and they'll charge you differently for it. This is with default components, and I think that probably will be fine, although 3 of them have a slightly larger load resistor by a minimal factor, which I don't think will affect it too much, but yeah, it's good to know. Good to know there might be a different performance from the other channels. All right, let's try YouTube chat again. There it is. Okay, now we got YouTube chat. And with my test message on there. How we doing? How was Sid Heresy yesterday? Enjoyed yesterday's stream. Sorry. My brain doesn't work. Really enjoyed yesterday's stream, tuning in for the rest. Hell yeah, thanks. Hey, I appreciate that. We've been sort of concentrating on Eurorack for a little bit on the stream. I would like to get back to all of my other projects, but I would also like to have a synthesizer during the work on the other projects. We're kind of concentrating on building up the multi, which is a utility. It's not a filter, but I was waiting on parts for all of the filters, which is this pile of circuit boards over here. So now I have all the parts I need for the filters. We also need to tune and test some of the other modules. So we're gonna change pace eventually, but first I need to install a whole bunch of specialty stuff. So that's what we're gonna be working on today. We're gonna get all of these jacks in. We're gonna power this thing up. And that's where the thermal imager really kind of helps out, because we'll be able to actually see if anybody gets a little bit too hot. And I can tell you right now, the 2 diodes right here, those will get hot. Those diodes will be transmitting close to their, well, not close to their limit, but they will be transmitting more than one might prefer. So they'll get a little bit warm. That's sort of common across all of the circuits that I built. I keep using the same Schottky diodes and they keep getting hot. But they're not deleterious to the operation of the circuit board, and they don't get overly hot. They just get warm enough to show up on thermals. So I think it'll be okay. But yeah, that's what we're excited. The pathway from reading words to my brain is quite short. So excited to follow along. Very interesting. Oh, cool. I appreciate that very much. Yeah, so we'll be able to get this thing on the bench. We'll be able to hit it with some frequencies. I think we can use the module, testing module that I built, if that thing still works. That thing has been through the ringer a little bit. It's not in great shape. It's some of the channels are not working the way they should. So we'll get the oscilloscope up and we'll hit it with a couple frequencies and we'll see if we can get outputs and inputs that agree with one another and we're happy with. Boom, boom, boom. I still need to figure out what I'm going to do with the Flipper Zero. This thing is like pretty capable and interesting and powerful, and a neighbor just gave it to me and then bought it himself another one. Yeah, I got to figure out what we can do with this thing. I mean, there's plenty of illegal applications that I could put on it. Big John knows. Maybe I'll have to sit Big John down and have him recommend stuff. He actually already did. Maybe I need to go through my chat logs and actually figure out what the hell. I loaded up some such software on it, and it just like had all of the applications in a spot, but it didn't run anything. Nothing will run. Nothing does run. It's clearly I don't run. Look at me. I'm huge. All right, tighten these up a little bit. Yeah. These need to be tightened. I need to put bolts in here so that I can grab the head of the fastener better, and I need to put Loctite on the threads because this is loosening. Sounds pretty good. Because I turn them in order to use them, and so when you do that, they end up unscrewing. But these were a good purchase. I've been having a good time using them. They work quite nicely for holding circuit boards in place. And they're quite strong magnets. Very good product. Oh, run the Joules. Run an ad. All right, running one more ad, and then we'll get started. Click. Makes this huge click noise when I do it because the synthesizer was plugged into the ad thing, the ad break thing. What I'm going to do when we finish all of these filters and stuff, I do want to do one more stream where I make something on the modular synthesizer, and then when an ad break hits, we reset. I think I like that format a lot because it requires me to have a fleeting attachment with the patches that I put together. So if I do something that's stupid, that everybody hates, I will move on. Like the marching drums thing that I put together that was kind of stupid. It's funny, it wasn't really putting the best foot forward because I had some like expert synthesizer. I think Sid Heresy was in the audience for that. It was like an expert in modular synthesis and making cool stuff. And like, I was making like alternative fart noises. It's like you put together like an entire patch that's like a symphony, and I'm sitting here going, well, this one sounds kind of like there's a poetry to that, but at the same time. All right, we can get started in a minute. 1 minute and 30 seconds, we will get started. Started. Get farted. I know, all that tech, and I don't have the filters, and apparently the filters are where all of the like really cool stuff kind of happens in a synthesizer. So I was unfiltered. I did not have enough filter to make genuinely cool stuff. I don't know how Julian and Dave do it, man. I guess they're just better musicians. They've been doing this longer, way longer than I have. Hopefully there is sort of some musical talent sort of hidden under the surface of all of this, well, fat, but somewhere in here, there's something good and musical. I was watching Vinny, Vinesauce Vinny, and he was playing this game that a bunch of other streamers have played recently, but it's basically a bunch of like wire bent hardware and then a sequencer, and you make stuff that you enjoy that sort of follows criteria. And I guess they had some kind of music analysis system in the game so that I could see things going, you know, I need the notes to go up or sound cathedral-ish, and so they had the ability to kind of analyze whatever the player was making. And so you had the basic experience of having a sequencer and a bunch of things that make weird fart noises and turning it into something that actually sounds good and cromulent and coherent. The game, of course, glosses over a lot of stuff, like for instance the fact that you have to make a child's toy sound like an actual instrument and mix in well with everything else. That's a lot of work, and the game, you know, has done that work for you already, but it was a cool game. Okay, that was the end of the ad number 2, and that gives us an hour and 28 minutes to stream and hopefully get some viewers, and then you know, we're gonna get this powered mult built, and it'll be fun. It'll be fun. We're having fun. Let's get started. Burp. Okay. So let's start soon out of here. Go to my setup. Start. This is all me poking at the Stream Deck to get all this stuff working. I have all kinds of like calibrations, and oh, we have to turn on the oscilloscope. All right, here, you guys ready for this? This is a Rigol oscilloscope. It's a top of the line current oscilloscope, and it is blisteringly powerful. It can do all kinds of cool stuff. Maybe it'll do our homework. It might do our analysis for us. Let me just clean out around it, because there's kind of a pile up of stuff in the shop that sort of engulfs things. It is the ever-present blob. These things are cool. These are just numbered wraps for like wires and stuff. But yeah, the Stream Deck controlling everything. And then, okay, where do I put these? These actually hang up somewhere else. So we'll just hang them up over here. Okay, so Rigol. This is the 914, the digital oscilloscope that has a logic analyzer hookup, although LVDS, low voltage dual signal, that's like $400. It's fucking ridiculous. So I have not bought that part yet. We're gonna have to design a circuit board for it. But I guess given our experience, it's not gonna be that bad to build a circuit board for. I'll just make it something that plugs in there, and then you have all your logic signals in the front. But I think the reason that exists is so that you can have a long cable go to your thing that you'll then plug locally into fast logic. And so the LVDS makes sure that the logic signals that get back to the scope aren't interference. Anyway, it's another thing to build because they made it ridiculously expensive. But okay, let's do this. Ready? Power on. Look at this thing go. Here we go. Here it goes. Here we're gonna any minute. We just gotta wait. It's good. Okay, there's the logo. There's the logo. The logo's there. Get excited, everybody. We got the oscilloscope, and it's gonna come up on, and the oscilloscope's gonna power. We've turned it. We pushed the button, and the logo came up, and we just need to. It's just you know, let it. It's gonna be cool. We're gonna do stuff on the scope. We're gonna do an analysis stuff because we turned on the scope. I hit the power button, didn't I? I think I did. Should I hit it? Maybe I should hit it again. No, I hit the power button. It's gonna power up. We're gonna do cool stuff on the scope, and we're gonna analyze. Oh, there it is. See, super state of the art. Stupid thing. So it takes like a couple seconds short of a minute to power up. Ridiculous. Because it's Android based. But because it's Android based, we've got some really cool stuff that we can do. Like for instance, where is it? Doink. I can have it up here. So I don't have to point the camera at the scope to use the scope. which is pretty cool. And this actually is a website on the intranet. It's a locally hosted site that I can go to, and I can control the scope with it too. So if I'm in another room and I want to analyze like the I don't know, something in another room, and I got the scope plugged in over there, I can put this thing up on the Wi-Fi, on the Wi-Fi hate. Boomer laugh track. Anyway, I can put it up on the Wi-Fi, and then I can analysize other stuff on it that's plugged in. Why are they called Eurorack? It originally started as, It originally started as telecom hardware, and with the electrical side of things, the original engineering of it, things like oscilloscopes and telecom like routing equipment and video equipment and stuff like that all had a 19-inch by a certain height in the inch standard as a standard, so that you could make big racking stacks of equipment and put it all together without making a big mess, right? It wasn't all like this thing is right now. So from that, synthesizer, people who are doing music and synthesis and cutting tape together in order to make electronic music, they said, well, most of these synthesizers have a voltage controlled oscillator, they have some kind of a filter, they have an amplifier, and then they have control signals. We could probably standardize this, and this could lead to all kinds of cool modules. It probably started from something else, but the rack size, the reason we have Euro rack is because of that 19-inch telecom standard in other equipment, standardization of other equipment. So the height was dictated by the original standard of electrical test equipment. And they went with that, and then the width, I don't know where that comes from, but I think it was pretty much the same origins. And so they standardized voltages, and then the voltages that the inputs and outputs would use and tolerate, and the power for the rack and all that stuff. So it sort of came about as these things seem like they're common among synthesizers. Let's make a standard. Look at this standard, we'll take this standard, and we'll make voltages standard. That's my understanding. It could be a little different in reality, but from what I read when I was originally getting into it, that's what I sort of gleaned. The MSDS sheet for Oh Bother is 100 milliliters of Oh Bother, glasses, human flesh, musical talent. I don't know if the musical talent is in there. I'm not sure. It may be. I don't know if there's some really talented people out there. So it has nothing to do with Europe. I believe Europeans came up with it. So that may be the origin. I mean, they still get credit for putting together other standards in order to make Eurorack, because the voltages weren't another standard. So. And then splitting apart the pieces of synthesis, I don't know where that came from, but it seems, Euro rack is the amalgamation of all this other stuff. So Dofer established the Euro rack standard. They're German. Oh, it was Dofer? I didn't know that. Yeah, the original modular stuff was a little bit more bespoke than what we have now. This is sort of evolved out of the original modular stuff. I wish my mixer circuit was useful for something else. I don't know if I should build up another one of the mixer circuits for myself. It's a little bit like too involved. There's like so many parts on it. It has two 113700, two of them, and these specialized op amps that I thought would be equivalent to TL074s, but apparently they're noisy. Julian said there was like a little bit of noise on it, and I was like, ah. It is extremely, and it's a big build too. It takes a little bit to build it, and I bought all these parts for it, and it turns out there's a European company that makes exactly the thing Julian was looking for $50, which is cheap for Eurorack. All right, let's get started. We've got like an hour until ads have to play. Because I've done mid-roll ads, and we preloaded the stream by running a couple ads. I'm just gonna move the fan because we're in heat wave number like 5, I think, or 6 this year. This permanent summer of heat waves is not cool. I had Willow in here. She was sleeping right next to the fan. She kind of collapsed onto her side, and it's very cute to have a corgi hanging out with you sleeping. But as soon as I get up and touch the streaming stool, she's out. She left. Oh yeah, no, the background music goes away. Sorry, I forgot that. Boink. Oh, I shouldn't have closed that. Oh well. Well, actually, let me open it. Control Shift T. Yeah, I had Willow in here, and she was hanging out and being cute like a corgi, and I look down and I see a spider crawling right next to her. I think it was a spider, but I had to grab my shoe and I sort of just killed the spider, and she was looking at me like I completely ruined her day, and then she stormed off. So no corgi down here today. We're working on the powered MULT. It's the thing that we were working on last time. I didn't even change the YouTube thumbnail. It's the same thumbnail. It doesn't even have part 2 written on it. Why did I do that? Because I'm not good at identifying the spider, and it looked like a really scary spider. It might have been a beetle. I might have not seen it properly, but it's either down here, it's either a spider or one of those millipedes, those house bugs. And those millipedes eat the spiders, so they're kind of bros, but kind of not. We have a pact. If I see the bug, I kill the bug 90% of the time. So I don't mind them being down here, but they're freaky looking. So Willow has already stormed off. I was saving her from a spider that could potentially be a biting spider. Do we have brown recluse? Technically, I think we have brown recluse here, but I've never seen one in all my years living in the suburbs. But yeah, it was Willow's friend. Is that why it was moving so slowly? I think I might have picked up on it outside because I think I got hit by a cobweb out there, which technically is not a cobweb if there's a spider living in it, right? I don't know. How's it going, Haystack? How's everybody doing? So we're continuing from yesterday. It's nothing new. We're working on Eurorack modular synthesizers. They're all the buzz with the musical types that like to spend a lot of money in order to make alternative fart noises. And I've been engrossed in this for a year and a half now. And it's finally time to actually build something that can make cool noises. We did a little bit with this before with my little ad break stream. We're going to do another ad break stream, but this time I'm going to have more filters. I'm going to have more cool stuff that I can make sounds with. You're sick. Oh, ugh. Getting sick as an adult is the worst. I thought it was because you make Eurodance with Euroracks. Maybe you make Eurodance. No, it's a standard. It's a bunch of standards in a coat, but that's standards. The whole point of Eurorack, so you've got all this equipment, you've got all the stuff you need in order to do sound synthesis. Sound synthesis involves making a frequency, altering the frequency in time, and sometimes even sequencing it, but not really. You can hook it up to like a piano and then you're the sequencer. You use control voltages, you use triggers, and you use oscillators and filters. Those are sort of the main components. Now, there are topologies to synthesizers. What goes into what? You don't start with a filter because you need audio in order to use the filter. Unless you have a microphone, but then you're the voltage controlled oscillator. You hit me with a taser and I go, ooh. And you hit me with a 9-volt battery, I go, ooh. See the high, low note. Anyway, if you standardize all that stuff, then the topology is anything you can come up with. So I can plug audio into a control signal and it's not gonna blow up all of my equipment. Easy peasy, right? You mix all that stuff together and you get things where you go from a filter to a control voltage to something, and it can just be crazy, right? And that's Eurorack. So you get all these modules, you put them all together, they have a unified power supply, so you don't need to get a bunch of special equipment, and then you can just plug stuff into other stuff until cool fart noises come out of you or the synthesizer, it doesn't matter. That's Eurorack. So that's the cool part about it. There are a couple other like similar standards. Eurorack is the one that really took off, and so that's what we've been working in, right? We need an 8 oscillator Minimoog clone UNC. Are we related? Anyway, so you can do anything under the sun. You do whatever you want in your walled garden, and you can make cool noises. A lot of the time people do this just for the fun of it. You just put together some stuff and you go wham wham, and it's, hey, that's cool. That was fun. You don't do anything with it. Some people do it to make professional music. Some people are extremely talented. I'm doing it to learn how to do it. That's kind of the primary motivation, is to learn how to do this stuff. I have no desire to spend thousands of dollars on equipment, and I've discovered through my friend Julian that you can just buy the circuit boards for this stuff. They will sell you just the circuit board, even if it is advanced surface mount technology. They say, here's the circuit board, good luck. We might have a tutorial online, but probably not. And so 3Toms was nice enough to sell Modular Addict a bunch of their MS-22 circuit boards, and I have created a module from scratch that I could have bought for $400. So that's, and then I dropped it. That's the cool part about modular synthesizers that gets, oh bother, up in the morning, basically, is that they pretty much just say, sink or swim, here's a circuit board. I love that. I love that because I'm an electronics expert, and we've been doing digital stuff pretty regularly, like stream interaction things, the fart noise maker, the ad block sign, all that stuff is like, you know, the idea lights and things like that. They're all like systems integration and digital. Modular can be very, very analog. And so I've been learning a lot with the analog synthesizer stuff. When it came to my synthesizer, Julian went, well, you're missing a couple things. You need filters. You need some kind of a multi that doesn't alter the voltage levels. So you need like a powered MULT. And so on the list, there's like a list of things that I needed. So the powered MULT is something that we're tackling right now. We took to Fusion 360 and we took to the internet. Oops, wait. The internet. There we go. And so I researched on the internet, and that primarily involves looking at Reddit because forums are dead. Unfortunately, we killed the forum. And so I was looking on the Reddits, and I found the modular or synthesizer DIY section. And so people had all kinds of different suggestions, including for the LED circuit and for output resistors and stuff like that. And people shared with each other circuits that they like, and I stole that information to make my powered MULT. So for the LED circuit, we have this mutable instruments circuit here with a 1 mega ohm, oh wait, hold on. Okay, so what's happening in this part of the circuit? Well, it's easier to explain if we view it like a normal circuit and not like the machinations of Emily Gillette, where they've apparently, Dave fits better in the sentence, sort of twisted this thing to kind of fit in this part of the schematic. This is what I'm talking about with schematics, where you're actually just programming what should be connected to what. What are you guys saying in chat? Critter organelle, pure data patch. What are these words? We need an 8 oscillator Minimoog clone. I would be glad to find a Eurorack module in the market in which to run compile pure data patches. I don't know what that is. That's confusing to me. Critter and Gutierrez organelle runs pure data patches. Oh, so like running, I was thinking about doing something like that, but instead of actually having like a digital module, it would be those like 4-pole, what is that thing where you modify, you take an I2S data stream and you put it into an FPGA, and then the FPGA can run a particular type of filter and do all kinds of weird stuff to audio, and you have 4 adjustments on it. You have 4 poles for that filter, and I would just put those to knobs. And so it would be this whole like FPGA module that would alter audio, but it's literally just 4 poles of a filter, and it's madness. I don't know what that would do though. I don't know how that would work, which is why I want to make it. But yeah, I'm largely analog for the audio stuff. For the sequencing and the control, I'm willing to go into the digital stuff, but I'd like to stay relatively analog, and even the digital filter that I got from Nonlinear Circuits. Nonlinear Circuits is awesome, but the digital filter that I got from Nonlinear Circuits, this is it's a digital filter synthesizer. It uses a bunch of flip-flops in order to lower the bit rate of the audio. This looks dim. What's going on here? I mean, I feel dim, but this looks dim. Mode button on this does all kinds of different. There, that should be full power. Huh. Yeah, I'm just too used to this. Okay, so let's talk about this. What is that doing? This is part of the powered MULT. I use Fusion 360 because I have a bunch of parts that I like in Fusion 360, and it makes these really cool looking 3D renders of your circuit. If you cultivate the 3-dimensional parts and you carefully select them to be things that you like looking at, that have the right details, and the pads you have are known, and you know that they fit and fully represent, then you hold on to those like they are your children. I don't know, maybe you shouldn't hold on to your children so much. That's getting a little concerning. Yeah, but you hold on to them tooth and nail, right? Because you want to use them time and time again. So the 3D render is a nice little bonus to this. I think this looks better than CirCAD with FreeCAD. What is the one that everybody uses? I think these look much better. They're a little simpler and they're not like shaded. They've got the right lighting. KiCad, yeah, that's the one. Nice, Baron Girmo. Got a 7-stream streak. I don't know about all this streaking that I see. You guys might want to put on some pants. But yeah, so the circuit for the LEDs came from an Emily Gillette design. I don't know what everybody did to her, and I'm here way after the fact, but she like said, screw you guys, I'm out to all of the modular people, and just left. And what she left in her wake was some very brilliantly composed digital and analog electronics. Creator of Pure Data is a mathematician doing his career in academic department, music, University of California, San Diego. We don't need the link to the college website. But that's what that sounds cool. Miller Puckett, the creator of Pure Data. So this is something, I don't know anything about it. I'm explaining everything I know. I came in here from the outside like a year ago. Celia Russo, thank you for the sub. Tier 1 for 105 months. I appreciate that. That's a lot of subs. Celia Russell's been here from like day 2 of the stream. It's pretty crazy. Theory and Technique of Electronic Music. I've heard of a couple books that I need to read. I should probably look at that one. I had a weird technical issue last night. My mouse was moving all on its own. After disconnecting the trackpad and unplugging my main mouse, it still was happening. Do you have a virtual joystick plugged in or something? What the heck? It's a gift sub. The blue light has been activated. Gondor calls for aid. Celia Russell gifting a tier 1 sub to the 4th person ever to watch my stream, LebTV Live. LebTV Live has been instrumental in making all of the interactive stuff that you guys enjoy happen. Where is, oh, this is the live streaming? Wait, coolest PS1 jungle. That's the wrong window. Hold on, that's the wrong window. That's the wrong window. All of this Node-RED stuff originated from LebTV Live's tutelage. He helped me learn how all of this crazy crap goes together, and that's why we can have an indicator at the top of the screen when an ad starts. Now, I'm gonna have to find a plugin, or maybe I can make a timer in Node-RED and pipe that into the thing that's shown on screen so that we have a countdown timer that's below the ad break thing. Okay, why are we okay, thank you. I'm not gonna look at Pure Data now, but if you, like, that's what the Discord is good for, is recommending things like that. I am not going to stop stream and go read the book. Like, I appreciate the recommendation. I'll take a look at it later, but right now I'm struggling for my life here to explain why I put this stuff where I put it. So, my stream. My stream. My stream, me. Anyway, over here. This is the circuit that's powering just the LEDs. I'm explaining this first because it's like the first piece of this whole thing. What we're doing is we are dividing the input with 2 1 mega ohm resistors to make it super low current and probably half of the voltage that was there before. And then we put it into a non-inverting amplifier where our feedback is going through the LEDs. R22 is just the current limit on the LEDs themselves to ground. And so with ground, if our signal goes above or below, then we get our feedback signal through it and the LED will light up. So this is just a way to give us more fidelity out of our LEDs, because if you just put them on the feedback loop, what you get is nothing until you reach 1.2 or 1.4 volts, whatever the voltage drop is there. So that is the, oh my God, man. Okay, so, oh, thank you very much for letting me get back to my stream. Okay, so, usually there's a 100 kilo ohm here to have some kind of a load, 100K to ground. I got rid of that. That was in the recommended circuit from the Reddit thread. The Reddit thread didn't necessarily recommend a specific circuit for the MULT, but what it did do is point towards a couple things. So there were, let's close some of the stuff that I don't need. Okay. This page was recommended from the Reddit thread, and it's talking about compensating for large capacitance loads. Like for instance, if you plug in a bunch of long cables, multiple long cables into the MULT, you don't want it to alter the voltage level too much because you've got some very sensitive voltage levels. Eurorack came up with the standard of having plus minus 10 volts. Plus minus 10 volts. Well, it can go up to 12, it could go to 8, it could go to minus 5. It may be a standardization, but it's more like these things are designed to work within these specifications. Anything goes, and so you can have some hot audio that goes well up. What about recommended? You can go up to like plus minus 10 volts on these things. You can have a voltage per octave signal that goes plus minus 5 volts with a 10 volt spread. And so when you have 1 volt per octave, all of those millivolts are going to represent specifics of the notes that you want to play. If you alter that voltage in any way by plugging into your multi, then anything goes, right? You suddenly you're playing different notes. It's not a good thing necessarily. So what I'm trying to accomplish is not having the capacitive load affect our multi. So that's what this kind of compensation techniques for driving large capacitance load with high-speed amplifiers. This is more like a professional EE thing, but it ends up coming up with a pretty decent circuit that we can implement in order to drive our output. And so we've got this like load resistor, current limiting load resistor here. We've got our feedback running from after the load resistor, and then we have a capacitor in here to snub high frequency oscillations and things like that that can occur. And so I copied that circuit, and then I used values that were in the simulation from an article on Mod Wiggler. That's in Discord. I'm trying to put this all together. Somebody was talking, you know, hey, powered mults, what do we do? And then there's just chaos. Everybody's talking about everything, and it's a forum, so everything is distracted, and then they start talking about other pieces of equipment, and it just goes off the rails. I didn't read any of this. I just looked and saw, hey, somebody simulated a non-inverting input, and that's pretty much what we put down, and that's what we built. So we have all of the circuit elements down there. We just need to get the jacks on there. So again, these are my sources. This is where I came up with the circuit that we built. And it actually turns out we don't need a resistor to ground. I don't know where I got that idea for R2 in here. If I want the MULT to like attenuate or alter this in any way, I guess I could build it up with that resistor in there. But this run on the PHBB, yeah, those are common, and I guess Mod Wiggler still runs, but PHBB is like so many of the forums that I was on. Thou shalt measure the voltages. Yeah, that's what we're going to do. We're going to make sure that everything's good. Do not get me working on negative voltages. I had a bad sound out of an Amiga. That's back when they used the negative 12 line that's on every power supply that nobody uses anymore. It's crazy. It's not very powerful, that negative 12. They put it in there ceremonially. Rebuilt it again, bad sound still. Yeah, so the negative 12 line going in, I don't know if you're probably not using modern power supplies for an Amiga, right? But that it's like a vestigial negative 12 line. It's ceremonial. It's there just to be there, because things will use it as a reference, but like generally, no, we're not working in plus minus 12 volts anymore. But all the Molex standard still has it on there. So if you buy a power supply off the rack, they have to sort of cater to the standardization, and they have to put a negative 12 on there, so they sort of like do it as shittily as they can. Yeah, negative 12's audio for audio and RS2. Wait, RS232 uses, I didn't know that, uses negatives. The way we do this now, in order to represent a wave, is you just basically choose where you want 0 to be. So in 5 volt audio, you'll have 2.5 volts, that's the 0 line, and then you go back and forth on that. You're basically DC offsetting your voltage, your wave. And actually, Emily Gillette, in her digital designs, will do that. They use a negative 10 volt source in order to offset a plus minus 10 volt and then squish it down to 3 volts and put it through an op amp that can't go above 3 volts and can't go below 0. So when you do that, you're limiting it so that you don't blow up your microcontroller's analog input. It's pretty cool. RS-232's plus minus 12 and plus minus 15 is okay. That's crazy. Retro USB power, is that the so RS-232 is in fact plus minus 12. Wow. The D sub connector is a forever technology. There will be giant space stations in worlds hundreds of light years away when we're just brains in jars, and the brains in a jar will still be connected to something with the DB25 connector. I think that is a permanent mankind technology because it's human-sized, you can solder it easily, it can carry a boatload of power on many, many different pins, and it is nigh on impossible to plug in upside down. Anyway, that's just my opinion about that. Okay, let's get these things built. Let's build a MULT. I'm probably gonna run out of jacks really quickly if we start manufacturing these, but I wanna make sure that this thing is suitable for building. And so what I've done off camera, oh, what did I just break? Did I break something? Oh no, I knocked down my little guy. Let's put him back on the light bulb. I should probably get one of the wooden light bulbs, the wooden light bulb holders over here, because this thing's kind of cheap. This thing goes on the wall. Most times 0 to 5 works too, but old PCs demand a negative voltage. Yeah, I'm not too keyed up on my retro systems. I was there, you know, I was there in the from the mid 80s to the late 90s, and I was gone for the 2000s. It just didn't exist. I stopped existing for a little bit. Financially, it was better for me to just not exist. All right, anyway, so I've already printed out this front panel, and these are evenly spaced holes, I believe. They're not based on this design. I could easily bring the powered MULT into a front panel design, either with a PCB or with, you know, Fusion lets me do that, and I know hashtag AutoCAD ad. We're not running an ad right now, but I do love how this program can both build my super duper circuits, and then it can also make the front panel, and then if I get confused about what R4 should be, it will show me where R4 is. I like the integration of all of these tools. It did not show me where R4, why did you not show me where R4 is? Where is R4? There it is. I see you. I see you, R4. I see what you're up to. I don't trust anything. You better watch yourself. Sleep with one eye open. All right, anyway, so we're not installing that resistor to ground. It's one component that we're just not putting in. If it is deemed necessary at some point, we can do that. It turns out my capacitors were actually the right size, even though their footprints seem like they're a little bit restrictive, and it might be easier if I go back to the other footprint. I'm okay with this, and I'm willing to just leave it. I believe this is a verified, decently sized part. The 0603 capacitors aren't quite as regulated in size as the resistors are. The resistor size denotation is a denotation of its dimensions. It's actually in mil, which is the fun word we use to describe millimeter. Oh wait, no, not millimeters. It's actually mil scale is an inch scale. It is an empirical scale. It's fractions of an inch. It's 0.0001 inch or something like that. It's like with the European scale, when we get down to like small sizes, like small stuff, we actually do start to divvy it out by tens, like we should have, like the Brits should have originally. America gets the blame a lot for still using imperial, but it's technically we don't. For all engineering purposes, we're in metric. Mil scale was because America invented everything cool that's electronic ever. No, we didn't. But anyway, the English scale was the original implementation of all of the scales of electronics, and that's why we have 2.54 millimeter spacing on things like solderless breadboards and on the IC spacing of through-hole chips. We need adapters to pull it over from the surface mount sizes because those are in metric. So pirates are to blame. That's a walk around the block that we don't need to take right now. So the last thing we have to do. Yesterday we almost fully put together one of these circuits. We figured out, even without my sources, what the values should be. Now that we have my sources, we know what the values should be. It's very simple stuff. It's 1K, 100K, 22 picofarad, the usuals. That's not true. You have Euroracks. That is because, once again, Eurorack uses Imperial Telecom standards that came first. So it is true. All right, so I have ThonkyCons. I don't know if I'm going to have enough ThonkyCons. You can buy ThonkyCons from thonk.co.uk, and there's an important lesson about the ThonkyCon connector that is really important to know. But first, an ad. No, I'm just kidding. Hold on, let me get my windows back into the right place. We had a window that wasn't supposed to be here. This is not it. It's this one, the one that I use to monitor whether or not I need to talk about ads. This is the, I'm not a pervert. I'm not a pervert. This is the music that we were playing. Coolest PS1 jungle mix, if you guys are interested. There's a bunch of these mixes and they're really cool. I'm not a pervert. Okay, let's keep this stuff up. Let me put this over to another window. I've said pervert. Now all of YouTube's algorithms have flagged me and they'll never let anybody watch my stream. Pirates raided the ship transponding the measure standards. Huh. Well, that's certainly a generational fuck up if I've ever heard of one. So, last time on Oh Bother, I powered up for most of the episode. Oh, here come the weed whackers outside. Oh, ThonkyCons, that's what I was talking about, sorry. ThonkyCon connectors, really important thing. This is the ThonkyCon connector. It's become the de facto standard for Eurorack plugs. We use an 1/8 of an inch or 3.5 millimeter, I believe, audio socket, which is a tip ring shield. It's actually called a TRS socket. The TRS was designed to have also like data on it, but it's right and left audio and then ground. And since we're in Eurorack, we're only sending one signal per cable. So we just have TRS or tip ring. No, TS, tip and shield. And so the tip will displace this little piece of metal. And so this pin will be connected to the tip. When it's unplugged, it'll be connected to this here. So it's a little switch inside the jack that's kind of a clever thing, and it also allows for a little spring to hold on to your jack. Up here, we can attach to a front panel. It's a through-hole device. It's got little pins on the thing. One is for ground. It's a through-hole device, and so you've got the ring that contacts this. This also holds it to a front panel with a nut, and the nut pulls against this shoulder here of metal. It's an important thing because that's metal, and this rivet connection down there, you can see the metal is folded onto a panel that connects us to the ground pin. That will extrude through your jack very easily because it's cheap. So these not quite ThonkyCon connectors that some people like to use, cough cough, nonlinear circuits as earlier designs, these, if you tighten them down with anything but your fingers, will extrude the entire barrel piece through and disassemble itself. And it'll no longer hold on to a plug. So, in the States, we actually do use metric standards for our empirical measurements. So we may, we may measure the distance between highway exits and miles. We tried in the 70s to switch over, but the boomers really screwed it up. So maybe when the boomers are all dead, we can try again. I would hope we can, but this is one in the midst of extruding itself through from being tightened with a wrench. So do not buy these. These are not the ones to buy. You want to make sure that you're getting the ThonkyCons that have the shoulder at the bottom. You can still buy these because some designs require these, but most of the designs that require those just have big open like pin leads, and you can put these in instead. So, US of A is more than 50 years metric. Yeah, like behind the scenes. I hope I don't run out of these, but ThonkyCon is probably the most economical way to get more of these plugs. Did I put this one in backwards? No, I didn't. There's a ground hole at the top. Okay, so to do all of these big through-hole plugs, the way to do is to plug them in and then solder them with the front panel on. So we're going to do that. So I'm just going to plug all these guys in. And then we need to get to testing this thing. We need to power it up for the first time. So I can create normal jacks by connecting a signal to the ring pin. Patching a cable will break the connection. Yep. And that's how you do things like what I've done is if you plug in one input source, it goes to both banks. So you'll have 3 and 3 of that replicated signal. But if you plug something into the other plug, it'll only go to its local bank. So if I plug something in here and I don't have anything plugged in here, it'll go to both banks. Neither of those emotes came through on my machine. I really need to fix my emotes. I'm going to run out of jacks. I'm going to have to go to ThonkyCon. That's not a convention, that's the website. I'm not seeing a lot of them in here. I used to have hundreds. Uh-oh, this is not good. Well, we'll test this thing today and I'll place my order in and hopefully it'll get here in time because I'm going to need a lot. The thing about the Eurorack modules is that you burn through these jacks. And I've got 4 filters that need jacks. Oh boy. Oh no, oh bother. Get it? Because it's, did you guys get it? I don't know if you guys got it. I don't think they got it. I don't think they got it. I love and hate that emoji combo. Gonad has recently retooled all of his emotes to be cats, which is, I think, is hilarious. It's awesome. By plugging these in, we're making sure that they're all in alignment. I didn't leave a lot of room for the pins on these. I went with the standard, what the ThonkyCon actually calls for, which is a pretty narrow jack, and I'm glad I did, because if I didn't, I wouldn't have room to run traces on the PCB. So I'm going to plug this thing in, and then I'm actually going to put a nut on these, on the ones that are soldered in. So the ones that are above the ICs of this thing have been soldered in because an SO14 IC doesn't fit under the ThonkyCon, but it can if you make your pads very small indeed. And so that's how I've done it. I've cheated. I cheated. I guess I could have used TL072s, the two amplifier version, but I don't know what that would have, I don't know what that would be 4 chips on this thing, right? I think getting the 4 amplifier chip is cheaper than getting 2 of the 2 amplifier chips. But if I did the 2 amplifier chips, that would mean that a lot of this stuff would be sort of occupied. And I think I got in just under the wire with this one. Without getting tricky with the vias and stuff, I have a relatively straightforward design, and it uses 2 TL074s. 4 TL072s might have been a little bit much. The Yanni Cat emotes are so much more expressive. I went with the PPs. I watched the PP documentary, and you know, I believe that the internet has taken back PP from the horrible people that sort of, I don't know, what was the word that I'm looking for? They kind of stole them for their memes, and they think their memes are so superior to ours, but they're not. Sometimes they're just dumb. All right, let's get this thing soldered. No tricky special things for this. We can just use our normal. Yeah, it's the frog guy. There's a whole documentary about him. It's actually kind of a really good documentary. There's a lot of good animation in there too. The creator of the actual original comic that was conscripted by horrible people. All right, so this is the powered MULT up close. We got version 1.0. I got my, sorry about the shaking. The microscope is very sensitive, and we have it tuned up to get a nice big view of these very small components. This is the minimum size that I will ever go to for surface mount, which is 0603. There's 0402, and it is smaller, and it does take up less space, and it would make my design a little bit easier for the designer, but it would not make the design easier for the me. I love those emojis. I know it's so much hate folks thinks it's behind theirs, but I don't care. I find the cute expression. And that's really the origin of PP, is just that he's cute. He's just cute. And he's supposed to be a little goober, not a little goose-stepping goober. So yeah, here's the 074s. Listen, I think this is a detriment to my design, is the fact that the TL074s that I got have the least professional printing on them. That's probably why they were the cheapest ones I could get, but like, oops, hold on. Here's a different surface mount chip, and it's got much more professional printing on it. I think this makes it look like It makes it look like a, I don't know, cheap. It looks cheap. I don't know. That's just me. That's just me being a weirdo. But anyway, they'll work just fine. We're gonna see if we can get some information on how my circuit performs using the oscilloscope. The components are so small, it's quite fascinating. It's hard for me to communicate how small these components are to you guys because we're way in there with a microscope. If you look at, I guess the hand cam exists for a reason. Get that in focus here. The hand cam exists for a reason, and this solder is, what is it, what is the width of this solder? 0.6 of a millimeter is the width of the solder that I'm using. 0.6. Oops, we're on the side that I can't solder for those. Let's twist. Let's get it twisted. Yep. Yeah, so I decided to build this thing in 2 HPs, so 2 horizontal positions. Because it's a utility, I don't want it to take up any space. The more stuff that I can build in 2 HP, the more integrated into Julian's synthesizer they can become, because his is built to travel. He takes it places and he uses it in all kinds of different locations. So I feel the need to take up an absolute minimal amount of space on his rack. 0201, oh no thank you. The problem with the surface mount sizes is that the difference between the sizes, there's a difference between the sizes, but they all look the same. They all are just squares. And so when you go down a size, when you go down like 2 sizes from 0805, it still looks like you're soldering in your normal 0805. You're just bad at it. It's your fault for not being able to stabilize the iron better, right? It's crazy. Okay, there. I gotta be careful of the plastic of that header. I decided to use the yellow header on this because now it looks like McDonald's Play Place. I tried to hand solder that, but most got stuck onto the soldering iron. I have irons that can go that small, but I would assume, yeah, it's just absolute frustration. And like the size standard, 0805 is a very old size standard, but it's compatible with the big, you know, human in the room, with the gorilla in the room, which is why we use those sizes, because they don't give me the brain vein when I'm soldering them. Tantalum capacitors, probably a mistake on my part. I probably shouldn't use tantalums in a design like this. It's better to use electrolytics. Tantalums are very sensitive. They have a limited amount of voltage, and they're expensive. But everything's getting cheaper, but also simultaneously more expensive. So I think maybe the tants are okay. Going forward, I should not design with tantalums. I should put big electrolytic pads down that could be filled with tantalums if I feel like it, but generally shouldn't. But that's a design thing. That's a design thing. It's very tempting in your initial designs to use tantalum capacitors, but you'll run into like, what, $4 for a cap? What the hell? So... Now, if I wanted to be super duper professional and not a streamer, the way that I would assemble this is section by section. Start with the power supply, power up the power supply, make sure your power supply works properly, and then you would put one of the amplifiers down and build up individual pieces of the circuit, and then double check as you go. Powering up the power supply from your bench supply slowly and keeping an eye on the current consumption, giving it lower voltage and then sneaking it up with the current limit on the power supply. That's how you would do it professionally, but I'm not doing it professionally. I am just going to plug this thing into the tester and we'll see what happens. Tantalum firecrackers. I don't think I've blown up a tantalum that hasn't just sort of fizzled. They usually just fizzle for me. Yeah, we'll see if any of these parts are actually rip-offs when they blow up. All right, check over our work. Yeah, these things I bought recently, and I put silicone rubber hose over the fronts so that they're temperature stable. Everything on them is metal. The magnets would be the first thing to go from any high temperatures, but it's far enough away that that won't really be affected. And so these are really good for using the air station, because they separate things quite a bit. And so your hot stuff can be suspended up on the thing. And so we've been using them for soldering basic stuff for a little bit, and they seem, I'm liking them quite a bit. I think I need to put thread locker on that, and I need to maybe find a bolt, like a hex bolt that I can put there, because when you're using them, you actually twist the head of the bolt and that loosens the whole thing, and you have to tighten it again. And the way I found to tighten it is instead of undoing 2 hexes and finding a Phillips head, ridiculous, I just grab them with the wire cutters and hand tighten the magnet. So I don't like that. We can get around that, and I can use thread locker on that, and then I could have it be a little bit loose so that this can twist, or not, or I can tighten it to incredible amount, because I just undid what I just did just by moving it a little bit. Annoying. All right, anyway, that's the sort of duckbill hangers. They can also grip stuff back here too. So powered MULT from Twitch TV/OBother. It's even got a chef's hat. That's a chef's hat. That's a chef's hat. 2 days in a row you're streaming? Yeah, sometimes I work for a living and actually do stream. I might stream tomorrow. I'm debating it. I probably should. You missed a meeting by oversleeping. Jeez. Okay, we've got LEDs on this, and I don't have LED holes, but we'll just observe it from the side. Let's plug this thing in and see what it do, whether or not it's actually going to come to life or anything. I think the first test is to just plug it into the module tester and see that it's sucking down a little bit of current. If this were not streamed, I of course would be doing this in less of a cavalier way. I would be actually like being careful and testing things, but instead we are just going to plug it in. So get the solder out of the way, solder braid out of the way, and just clear myself a little area. I've got a test plug here, and then we have my bespoke module testing module. That barely works. This thing barely works. It barely works. Fortunately, it's had a time. It's had a bit of a time. All the buttons have broken off. Some of the channels work, some don't. I have to hold on top of the I2S audio thing. What this is a Teensy 4, no LED screen, a couple buttons, Eurorack power supply, and then 3 2-channel I2S digital to analog, and then those go into amplifiers that bump them up to plus minus 10 volt levels. Curious to see if it works as expected? Yeah, me too. me too. And it all works off of USB-C. So all I need is a power cable. I don't know if I should use... I think I need to use the good power supply, because this is the USB-C power supply that I bought. It's been showing noise on some of the lines. So this is great for like recharging stuff, but is YouTube chat not working? It works. There's just nobody there. Yeah, this power supply we should use. This is something that Amazon sent me by mistake. It's much cheaper now, but at the time they sent it to me, it was during the pandemic, and it was like $75. And I was like, okay, that's the best power supply I own. And it's this little USB-C laptop recharger. And so I put that on the oscilloscope, because the oscilloscope uses USB-C. So I plug this thing in, and then I turn it on, and we get my testing thing. I used like an easy LCD thingy for Arduino. This thing is covered in shit, and it's lived a bit of a life. I'm trying to redesign it. I'm redesigning it with a bunch of 3D printed and VFD display stuff. So it will get better. Maybe not this hardware, but the other hardware will get better. So if I turn on my scope, I have 6 channels. And so I've got square wave and gates, high, low, low to high. I've got C2 note, 65.4 hertz sine, and then I have a 2 volt DC signal, which I think those are supposed to correspond to each other, maybe. I haven't gotten a definitive answer about that. I need to like look stuff up and figure that out. I have for low frequency oscillation, so I have a 0.2 hertz sine wave and then a pulse that comes in at 0.8 hertz. The problem is Some of these channels just straight up don't work unless I like push down on the thing just right. So there's some hardware issues with this. Like, that's supposed to be high to low. Come on. Just give me a little something here. Come on, you can do it. Ugh. So some of the stuff doesn't work. I need to do like a session with this thing. We at least get our sine wave, which is a 5-volt peak to peak. We can use this to start to characterize some of the filters. I have a frequency generator that we might be able to do a sweep with, but I'm alone. There's no one here beside me. You have a bunch of Twitch chatters that are reading your stuff off of my screen. So that's all I can offer you at this moment, at this trying time. I need a couple wires. I need test cables. 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 Where are some test cables? I think I have a couple over here. I don't. Where are all my module cables? Here's some. My whole Euro rack thing is pulled apart. I'm doing some stuff with a power supply on it. So I need to put it back together. So we'll have a couple streams of putting it back together and getting everybody tuned and running together. Show me your dick butt. Here you go. Standing on my mic cable. Okay, there we go. All right, so let's get some tests going here. First thing, I've got to plug this thing into power, and so I've got these current indicators under the whole setup, and those send power through those current indicators first. And since we are being completely cavalier with this, I'm literally just going to plug it in and see if there's a spike in current. Let me get the circuit board holder out of here. We'll just put it right there. I don't think I'm going to need it, but let's observe the back of the board when we power it up. Now, Eurorack standard puts power onto a IDC, insulation displacement cable. That's these flat cables that we used to have all over the place. Very old standard. They can carry a little bit of current on these lines, and the way that they have it carry an appropriate amount of current is by doubling up on everything. And doubling up on everything makes the connector symmetrical as well. So we have in the top row, this pin and this pin, those are opposite of the stripe, so they are actually plus 12 volts. And we actually start from pin 1, which is denoted by a red stripe on the cable itself, and then on most of the IDC connectors, you have a little arrow. And so that arrow is pointing technically to pin 1. And because everything is crazy, ICs, you count from pin 1 going down, and then you go over to the other bank and go back that way. That comes from vacuum tubes. These did not come from vacuum tubes. So the pins are 1, 2, 3, 4, 5, 6. So you got odds and evens. It's different. It's confusing. You got to just know. Which microcontroller standard for audio have you been prioritizing? Prioritizing, it's a weird way to say it. I've been using I2S, I guess I2C's sound equivalent thing, but I don't know, there's others, you can use SPI. But anyway, so pin 1, 2, 3, 4. What Eurorack does is it puts negative 12 volts on this pin and this pin. All 6 of these are ground, and then these 2 are plus 12 volts. If this extends out to a 20-pin connector, you have 5 volts, then you have one signal and another signal, and that's not really all that standard. It's like a control volt, like an internally routed control voltage and volt per octave, I think. I don't know. They can be used for anything. Those last 2 are usually not used. 5 volts you can create with 12 volts. There's a lot of LM1117s in these designs. So you just take 12 volts and ground, and you can pretty much do anything. Negative 12 volts is there to make wibbling waves with op amps easy. If I plug this thing in to an unshrouded connector, I can have 12 volts on this pin, I can have negative 12 volts on this pin. Or I can have the opposite, which is really, really bad because that's a difference of 24 volts through your circuit. So in any design that I'm making or building or implementing, some of these do not have what are called Schottky barrier diodes. Diode, the common way to describe a diode when you're using analogies is to call it a check valve. And so if you have current running the opposite way of a check valve, it blocks the flow of current. What's actually happening is in the junction of a doped and undoped piece of silicone, you have an anode and a cathode, and at the junction between that silicon, you have another sort of charge field that is opposing it and does not allow current to flow. But when you increase the charge field at one of the ends of the diode, that junction, the barrier, will increase until it allows current to flow through. And so you can go through the physics, just look it up on Wikipedia if you really want to learn about it. I'm not going to explain all of it, but the Schottky barrier diode has a very low voltage before it starts allowing current to flow. What's up, Q? And so I put Schottkys in the path. I bought about 10,000 of these Tchotchkes, these little Schottky barrier diodes, and so I use them everywhere. They're a little bit undersized. They're going to heat up. We're going to see them heat up. That's not an indication that something is wrong. I'm going to look here at the plus 12 volts and make sure that it doesn't use up a ton of current, and then we'll try to put a wave through this thing. So I have denoted that the stripe goes down here by putting a little STRP marking, and then I have a big plus sign on the other side. This is not going to prevent dipshits from plugging this thing in wrong. It never does. But if you plug this thing in like this, you're gonna just short out your own power supply. So also, there's a little bit of width to these plugs. So technically you shouldn't be able to plug them in out of whatever. Anyway, so making sure that I plug this thing in the proper way like this, we're gonna look for a current spike. Actually, let me do this so it's out of the way. Doink. We got a little bounce, and then my tester shut off. Uh-oh. Okay, well, something bad happened. Turn off the power, make sure that I'm in the right orientation, plug this thing back in, and let's try again and see if anybody heats up. Uh-oh. Yeah, the power supply is going funky. See how it's doing? Full current, no current. There is some kind of a short. So let's go hunting. Let's go hunting. Let's go hunting. Okay, so tester can move. That's the whole purpose of the tester. Stop talking about Killer Paquette's pure data. Jesus Christ. By the way, can I relate that to the thing I've been talking about all day that nobody's listening to? You're doing the opposite of promoting this. By the way, Pujinki has helped me with a lot of stuff before. I do trust they're fine. They're fine. I'm being hard. I'm being a weirdo. Being hard on them. Oh, I froze the camera. This is going to cause a lot of issues. Stop talking about the same stuff over and over again. All right, so I need to actually stop this. So let's turn this off. Deactivate, and then reactivate it. Nope. Deactivate it again. I gotta come up here. This camera's, the little camera in the window is still active, but I gotta unplug that. This is a loose USB, I think mini. Loose USB mini is one of the most evil plugs that exists. I wish this was a screw type USB-C. We were gonna modify this, but I had a blowout from my DRO X-axis 2 years ago, and we have not recovered from that yet. So activate that, camera comes back, but it's all fuzzy. And I need to go to, on the desktop, I need to quit out of Stream Deck because now it can't find the camera. So you can't quit it from here, I don't think. Yeah, you can't. Is there? Yeah, there's no like quit. Okay, I can right click on it in the tray and quit it. Quit Stream Deck. I need to make a tile that runs a bat file that'll quit Stream Deck and then open it up again, so that I have a button that'll recover from my camera freezing. Or I could fix the camera. It's, you know, one thing or the other. Okay, so now stuff will respond to my camera, and I can go to the Stream Deck, the Stream Deck, and I can hit setup, and then micro procedure, and that runs an algorithm. It didn't switch scenes. Uh-oh. Oh, you know what? I need to give it a minute to reconnect to the OBS control. I think it should be good now. Nope. Oh, there we go. Is this... Oh, now that... Oh, no, it's not out of whack. That's in whack. Okay, so now that that's in whack, let's hit this. And now we're back. And we can go to the right scene. There we go. Okay, now we've got microscopy working again. Oh, but it's still, ooh, it's still bad. There's gonna be like streaks, you see that? It's this weird lag that goes on when the Logitech camera's not quite calibrated properly. Let me try running it again and see if that fixes it. Let it run through its course. Okay, let me see if I can fix this myself. So I go to properties, and then I go configure video, and then I take off the automatic stuff, and I do the white balance at 43, 42, and camera control, and we turn off autofocus because there's no focus motor anymore. And then zoom, we don't need to do anything with zoom. Low light compensation, don't need. Go back to the other screen, make sure everybody's okay. Click O, well, the gain's really high. The gain should not be that high. That's why we get streaks, is because of that. Oh, and then I need to turn the FPS now to 30. Click OK. Go back to the properties again. Configure the video again. Tool around with the settings. This is something that I've automated, but it appears to have not worked when the camera freezes. It's very annoying. FPS, we're going back to matched output. Okay, something should change. It didn't. Oh, over here, gain. The Vias on your chef's hat look like eyes. Oh yeah. It's a chef wearing a hat. You know, like, everybody's a critic. Okay, well, I don't know if I did anything. Let's see, does this look normal? No, it's still like super delayed. Why does it look so bad? Configure video. Oh wait, let's click OK on that. Oh, it's still coming up with the configure video things that I clicked earlier. And then video for MJPEG, color space default, resolution, yeah, that's fine. And then FPS resolution 30. Oh, I did mash output. I want highest. Yeah, see that? See how it just changed settings? It's not a micro. This is an operational amplifier. TL074 is a 4 amp op amp from a million years ago. Okay, is that streak free? Yeah, see how fast that is now? Jeez. Okay, now we can go back to this. Sorry about that. I moved the microscope and that was damning. Okay, so what we have happening right now is, we don't need to scope up. What we have happening right now is we have a runaway current. Basically, when I plug this in, the maximum amount of amps flow through it. So we troubleshoot that with a multimeter, and I just put this to ohms, and we start testing around to see what could possibly be the problem. This is a simple enough design that I do not think that there should be anything wrong, but there's a possibility that in soldering these two jacks in, something happened and it got to the pads of this power plug. I think that's the main... What is a chef's hat? You could Google it. I don't, like... guys... It's not slang for anything. It's, I drew the hat that a chef would wear. Because I'm cooking. Why is there stuff on my meter? What's happening to the meter? Wait, what is that? Huh, weird like stain. Look at that. What the hell is that? Weird. Snef. Look, it's not my fault that the H couldn't fit. Okay, I have some 770, what is it? 076s that are apparently, I don't know, noisier. Let's go running. 1 mega ohms, so that is the 1 mega ohm resistor that's on the amplifiers, although I think it probably should be a half a mega ohm because we've got two 1 mega ohm resistors connected to the circuit, to ground. So I mean, like this, from plus to ground, which this I believe this pin is. Yeah, that's the ground in between the two. Okay, so it's a fleeting mega ohm. 420K. Huh. And then 1 meg. So between positive and plus and minus, we're going to have altering. That little flashing that's going on is probably because we've charged some such capacitor in the path. 400K. I guess that's in spec. What about you down here? 500K. Why are we eating up all of the current? And that was the plus 12, not the minus 12 that was doing it. So something is getting through here and it's cursed. So let's just take plus 12 as it comes in after the diode and go to ground. 50 kilo ohms. It's not, that's not low, but it's also 300K is, that's on, why are they different? Okay, that's more like it. All right, so, I mean, what else could the problem be if it's not that shorting out? Are these in bad? This one's in backwards. That's what it is. This one's in backwards. I put this in up backwards, it's upside down. It's supposed to be that way. This one's upside down. How could I have done such a thing? Why is... Can't I just build a circuit without the single biggest fuck up of my life? Why? Okay, yeah, let's get it out of here. We can use hot air for this. We use hot air and I'll just pluck this thing out and then we can flip it around if we think it's still good. Although reverse voltage, it might have survived. Let's see if it survived. Let's pull it out and see if it survived. Everybody pull it out. Wait, no, I mean, hold on. No. That's not what I meant. Not what I meant. Not what I meant. So, hot air. Did you guys get a head injury? What's wrong with you? You guys look completely unfocused. Here we go. Hot air. I'm just gonna put flux on both banks. Although I think there's enough there already that I can still just use the flux that's already in there. Flip the other one around. So if I flip this one around, I'm going to use hot air on this, and I'm going to start far away just to preheat the board. You just want to get a little bit of preheat into the board, and then I'm going to come down and I'm going to kind of put the heat on it. I think maybe I should get rid of the 3D printed thing. I don't think that's really going to tolerate. It's debatable. I don't think these are going to get, like these especially, I don't think they're going to get hot enough to start melting. It's possible that they do. I got to be careful about that. But I think if I'm just very quick with the hot air, it won't propagate out to the ThonkyCons. I've had ThonkyCons melt on me before. I think the FR4 is going to be enough of an insulator if I'm quick. But I've just got to be careful that the heat that I'm sending in every direction doesn't get to something that's super sensitive to it. So flat panels that I want to remain flat, I will move. That means I got to do an alternate grip with the duckbill. Ugh, jeez. I mean, these are effective. They're just a little bit of a pain sometimes. Okay, so that one's going to get kind of toasty, but I think it can. And then take this little guy right here. I have this set to 500 degrees Celsius, and the air rate I think is like 8 or something. I think it's less than 8. It's a pretty slow air rate. I don't really know any other good settings for the hot air. I don't use it for that much. Usually I just use it to overwhelm an area with heat and then pluck parts away and we can rework the pads. I could also maybe just flip this with the hot air still in place, but I don't like holding hot air against the board that long because I've played with this thing before and I have seen it destroy pads. So we got to really make sure that all the pads of our IC are molten. The other way to do this, if you don't have a hot air station, which they're cheap now, you can get a hot air station pretty easily. You don't need a professional one to do stuff with hot air. But if you don't have hot air, it's not the end of the world. You can put something called Chip Quick on both banks of pins, and then this will practically just fall out because Chip Quick is a bismuth solder that lowers the overall temperature. When you alloy it with regular solder, it super lowers the temperature. It's called Chip Quick, yeah. And you get it by the bar. It's like a very stiff bar of malleable metal. You just kind of bloop it on both sides, and then your chip falls off, and you have to use desolder braid to get rid of it. You can probably use a solder sucker too, but you want to really just like get rid of as much of it as possible, and then you put regular solder back on when you rework the part. That's Chip Quick. Or the other way to do ICs like this, use a big piece of solid copper wire, plop it down on either side. You can have it loop around if you're really good, and then add a bunch of solder to that, and it'll short out all of your pins, but it'll also help you get them all to be molten at the same time. If you've got a soldering iron that's got like a tip that's a big bar, you could use that big bar to go bop, 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 and it'll eventually fall off. The point of this is to get all of these molten at the same time. Alternatively, if this chip is definitely dead, which it probably is, and you don't need to recover the chip, you can bend up the individual legs so that they don't connect with the solder, and then remove the solder from that pad, and that will disconnect your chip. But it is, of course, going to ruin the chip. The thing to be really careful about, and the thing that we're most sensitive to here, is that all of these become molten at the same time. Otherwise, I can be putting forces into the chip that are capable of breaking. Wait a minute. Oh, we can't use hot air because we got the pins that are right below this. Those will also be subject to quite a bit of heat. Is that still gonna work? Am I still gonna be able to pluck it from here without, I don't wanna use Chip Quick. I wanna just do this quickly with hot air. Well, let's see if we break anything. All right, so you guys can see on the hand cam where my hands are. Look where my hands are. Letting the days go by. Let the water hold you up. Circles. Hot air soldering, circles. Circles within circles. Regulate. Cells interlinked. Circles. 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 Circles within circles. Okay, so I'm going to put a little bit of pressure on the side here, just pushing lightly on the IC. And we're going to heat up the banks. And now I'm going to get real close. And he's out of there. That was a little too much pressure. I probably should have been a little lighter on the beans there. What's the word? I put this one in backwards. We're going to try to reuse it and see if it survived. But that caused an issue with the initial power-up. I'm just going to use desoldering braid on this because I don't know if I'm going to melt the plastic of the socket that's underneath it. So what you do is you remove the part, then you clean the pads so that they're flat again, and then you can put the part back in. If you're not under the restrictions that I am for temperature, then you can remove the part, flip it around, and put it right back in. Oh, this is off. Back on, iron. Hey, what's up, Q, Mahalo, Swizzle Circuits, Hoover. Magic String is here. The whole gang. I started pretty quickly today because I knew that we would be waffling around for quite a while, correcting mistakes and, you know, various other things like that. But see that the desoldering braid just kind of returns it back to its regal form. You got to be careful with desoldering braid. You want to make sure that your iron stays on it at all times. And that it moves with the iron, because if you pull it away from the pad, you can pull the pad. You can just pull the pad right off the board. Seed Studio boards are pretty good though. They've got pretty nice adhesion for the copper. If you're on cheaper, older circuits, sometimes this operation will lift up. Like if you've got a pad that has no connections on it, it will just lift it up. But the Seed Studio ones seem pretty good. Too bad I had to pay tariffs for these fucking things. I'm very mad about tariffs right now. They're so pointless. So, pin 1, as denoted by the little bobble right here, was not pin 1 when I soldered this thing in. I don't know what kind of situation I was under there, but I was not paying attention. Pin 1 is denoted by this 45-degree angle. And these ICs are not the ones that I like. I do not like these ICs. The ones that I like have a little dot on them, and they have got better silkscreen markings. Silkscreen markings on this are a little bit amateurish. They look like they're like big and weird and old looking. I don't like them. Let's see if I can use some of the solder that's already there. Is this like popped way up? What's going on? Oops, come back. Did I bend a pin? What the? Okay, hold on. This is right-handed. Father. Man, I'm all kinds of shaky today. Oh, they just have a little like residual solder on them already. They might be bent. I might have bent them because I kind of jumped the gun on putting it in. All right, let's just put a new one in and we'll test that one some other time. Let's put a new one in of these TLS74s. I got a whole bin full of them for this reason. These are something like 50 cents each, and at the volume that I bought them, they're less than that. So they were probably like a couple cents each at that volume. I was able to get the number that I got of these pretty cheap because of the volume discounts. Is this flat? I'm feeling, all right, let's take a look from the side. Probably should have sanded down that chip a little bit, or the connector a little more. I don't think it's sticking up that much. It is sticking up a little bit, but we can solder around that. I can't believe I put in one of the ICs backwards. Stupid. Now I'm going to do it again without even realizing it. I won't check, and I'll just drop this thing down and like try to put it back in, and it'll be completely the wrong way around again. Double check. That one's that way. This one's that way. Pin 1's that way, right? Hold on. TL074C. let's look at this data sheet. Look at TL074C. That would be a phenomenal feat in chat not backseating if both ICs I was about to install backwards. One person would be laughing at me, but the rest of y'all. TL07X. Down we go, down in my belly, all the way down here to the physical properties, where they probably don't even cover this package because it's supposed to have a little bubble instead of a 45-degree angle. Oh my God, there's a lot of variation going on here. This is a jelly bean of jelly bean parts. This is like the king of jelly bean parts. Pin 1. They're not really showing the... Yeah, there's the angle. There's pin 1. So the way that I had it, this is the correct way, because pin 1 is right there. I'm just making sure, because you get in your own head about these things. I can't, everything is in the way right now. Hold on, let's do that. I just gotta anchor the pin down first. Can probably manually solder all these. It's fine, it's not gonna take that long. You don't gotta be a super drag solderer all the time. Sometimes you wanna put on a fabulous outfit and solder, but today we don't need to. Although when it comes to that compressor, if we can get to that either today or tomorrow, I will drag solder all those, because that'll take an absolute lifetime to put all those ICs down. Ah, damn it. Okay, now stabilizing myself while doing this is kind of difficult to do, just because these things hold the circuit board so high above the desk that I need something like a wrist pad or an object that I can put under my hand in order to stabilize it for this sort of operation, so that I can move like I'm used to it moving. Okay, one pin is soldered, and so now we can go pin by pin and do all the rest of them. We're doing it like this because this is floating above the pads a little bit, because those pins for the socket are pushing on it. I didn't completely flatten them. I could have done a better job of that, but you know, this is just the first time building it, so. Turns out I need to order FonkyCon connectors too. I'll do that tonight. Fonk is making out like a bandit. Oops. I think that's good. All right, I'm gonna see if I can position myself a little better to solder these. Oh, ad starts in 2 minutes. Man, we made it an hour without that. God, that hour flew by. This is how to do them manually, pin by pin, without using drag soldering techniques. It's as simple as finding a comfortable position, heating up the pad, and I'm kind of touching the pin a little bit there, and then melting the solder against it so that it flows out on the whole thing. That was unacceptable. I didn't get enough solder on there. You saw the solder jump to the actual iron. I have this thing in the way that's kind of preventing me from getting the right angle on that stuff. So heat up the pad and the pin, solder to the pad and the pin. It coats everybody. We can still see its little footsie. But that is soldered, right? Yeah. Just making sure that we don't see like a little line. If there's a little distinct line under the little foot, then it might not be connected. It might have a cold solder joint. I'll send a fart during ad break number 7. I guess all of that advice was pre-ad. So in just a second, you guys will get an ad. Dun, dun, dun. I apologize for the ads. It seems to be hurting my regular numbers. We had a bunch of people here yesterday because of all the solder rework, but there were a lot of new faces, and I apologize, but that discoverability, the ability to actually get new people in here, is harmed by having pre-roll ads. Although pre-roll ads, I feel, are more fair, because I'm not really in control of any of this. I have to do one or the other. I would do no ads if I could, because that's what Twitch is originally, before Amazon got their filthy tendrils all over it. Twitch was, hey, I want to support the artist directly and not have a fucking Funko Pop ad come up in the middle of my program. I know, I'm very disappointed, but they didn't give me any control over it. So the IC is a little bit crooked. It's not quite as perfect as I would like it to be. If I put this through an oven and all of these became molten at the same time, this would correct itself. Or if I applied heat from the hot air gun for long enough, they would actually, the surface tension of the metal, because it's metal, not water, it has very strong surface tension. So what it does is it pulls on all of these at once, and the IC will actually work itself into the right position. But I don't need to do that because they're all making clean connections. Ad starts in 22 seconds. Everybody brace for the ad. Oh wait, it starts in 22 seconds, but then it 22 seconds, and then it says ad starts soon for about like 30 seconds. It's ridiculous. It's not, it should be a little bit more tight, but I guess it's going out to a bunch of people that have delays and stuff on their broadcasts. So we're just going to wait for the ad over here. Yeah, watch ads and oh bother gets us $1 million. If that were the case and I did become like a millionaire off of streaming, you guys would see some drastic changes around here. I know the ad's playing, so I'm going to talk about that kind of stuff. I'd probably be finding like a brick warehouse that I could stream from, possibly also living there at the same time. I would, oh man, so much. I would start a car project. We would do a car project. I might upgrade these cameras to better cameras. It would really all go, if I really did just get $1 million tomorrow, it would all go towards stream and trying to keep the stream like as good as possible. Still being cheap. I would still be as cheap as I am now, but you would definitely see something like a lathe. Is Swizzle Circuits just lashing out against having to watch ads? Is that what's going on? That's why we're getting the... I think Swizzle Circuits might be a little mad that we're running an ad break. Right on time. I did this. I did this to myself. This is my fault. This is my fault that this is happening. Can they sustain it for the entirety of the ad break? No. They got 1 minute and 50 seconds left. I'm sorry, Swizzle. I apologize. Unfortunately... Oh no, oh no, you started something. You started a movement. They've started to organize. The proletariat is coming for us. I need to hide under my desk. Get all my bank bonds. Let's get out of here. The ad breakers have started to organize themselves against us. Oh no. Well, those of you who are here that can listen to me legitimately, I appreciate you very, very much. Those who can hear me and appreciate me illegitimately, that's okay. I'm happy to have you guys here. I try not to run ads. The only reason I like doing it is because, well, like doing it. I don't like doing it. The only reason I do it is so that people can find the stream. And we have seen a lot of new people in the stream, so that's really cool. So, anywho, we're waiting to get back to the powered multi. We flipped the chip around. I'm gonna wait until I get my high sign that I can start talking about the project again, which is for this light here to go green. It's got like an 8-second delay on it, because if I try to start immediately when my tools tell me that the ad is done, it's not quite done for everybody yet. It takes a minute for everything to snap in. I've been watching Sput because he's been playing Approximately Up, which is a fascinating game that I might buy just to teach myself more control systems. But Approximately Up, when watching his stream, Sput stream, I don't know what settings Sput has on his stuff, but when he goes into an ad break, the ad break blocker script that I've got going on has weird stuff happening where the audio will play old audio. The image stays, and I think it's live, but I'm not sure. But it plays like clips of old audio, and the ad break goes on infinitely until I hit refresh when I feel like it's been going on long enough. Ah, here we are. We're officially back from the ad break. Welcome back. 3 is the squirtiest. Listen, you guys can map out the random fart noise maker. Each one of these numbers that they're redeeming corresponds to one of 9 specific farts that are in the fart noise maker, which is a dollar store toy that 3Mares sent in. And we made it an Internet of Things thing with a nice speaker. It's got a Harman Kardon speaker, one of those ones from the clear Apple speakers that are worth so much money these days. All of the foam on those have melted, but this is a slightly more modern one. So I have 60K channel points. Yeah, Swizzle was acting out against the ads there for a little bit. All right, so we've soldered the new one in. I'm pretty sure, yeah, that's making a connection, right? Boy, does that look cold welded. No, that's in there. This one actually looks cold welded. I'm gonna cold soldered where there's like a little break in the solder joint. Just gonna give that a little bit of extra solder so it looks like the other ones. Next one that I build, I'll have to shorten the pins just a little further so that they're completely flat, and then that makes installing this IC a little bit easier so it's not floating above the board. Okay, so new IC, this one is in here in the proper orientation. Our pin 1 is now pin 1, and we are not reverse voltaging either one of these. I was thinking, like, what else could go wrong with this circuit? There's like nothing to it. It is a power supply, and then it's 2 TL074 circuits. That's it. So now that we've corrected that, I think you're gonna like the results. I think you'll like what you're gonna get. What is that again? I think that's like a Men's Warehouse commercial. All the Europeans have no idea what I'm talking about. Okay, we won't put the front cover on this thing, and let's go back into this mode so we can see what's going on. Let me just get this hardware out of the way. Actually, let me get the hot air out of the way. This thing is a little bit annoying. Yeah, I would definitely, like, if I had $1 million, if I won that $1 billion Powerball ticket, the differences you would see around here would be a little bit more desk space because I'd move all the computers into a computer-like room, and I would switch locations. We would be in more of a warehouse. I'd probably start a car project where we'd do way too many modifications to a resto mod, and then stream would continue, like, because I enjoy this. Okay, so let's get stripe right. Stripe is there. Stripe is here. This plug in. This make a boom noise. Does this interfere with the module next to it? A little. I can't really do anything about that, though. I can't move it any more than I've already moved it without getting in the way of other stuff. It's possible I could have moved it a little further, but in any setup, it would have to bend the pins so that they go in a little bit. So this would be able to plug in. Unfortunately, I can't really do that. I have close to 300K. Maybe I should play some farts. That's entirely up to you. Listen, I'm not... No. Actually, I should probably have had it go this way, because then the flat part would have been like that. That would fit in better. I can't do that, though. The part with the nub has to plug in that way. Damn. Huh. So, yeah, one piece of advice is to do the plug the other way around so that the keyway is facing into the board. Well, I've got 10 boards that have this design, so we're gonna have to make it work. Let's see if this blows up my desk. Little spike in -12. This isn't coming on. We're still shorting out. LEDs are lighting up. Okay. Now, is that an inrush or something else? What's hot? Capacitor's hot. Why would that get hot? Is the capacitor in the wrong way? According to this, no. Because positive comes in, goes to the Schottky diode, over here, to the positive lead of the tantalum capacitor that's 35 volts. And those go to ground. And the negative, we've got positive on ground because that's more positive than -12. And then -12 comes in, goes through the diode, or rather, ground comes in, goes through the diode to -12. And then positive through the diode, that's in the right direction, yes. TL074 orientated correctly. Why doesn't this power up? What else could be happening here? Some component short to ground? That's in the proper orientation. None of its leads are shorting. My other suspicion is that the ThonkyCon connector is going to ground on the power supply plug. But we tested some of it and it didn't appear to. I'll let it cool off and maybe use thermals on it. Or we go back to the multimeter in order to test it. I don't know why, immediately failure. It's very annoying. This is such a simple circuit, like there should be no issue. It should just work, right? It should have worked. I designed it to work. I didn't design it not to work. The green LED lights up too, which is fascinating, but... All right, so let's see here. Bring back the multimeter. I would expect to see like low to 0 ohms on some of the connections if that were happening. But we're gonna test some of them now, because well, it's -12 was acting funny. We didn't see a current spike, did we? We just saw this not work. It wasn't able to provide the amount of current, but it's TL074s, so they're nothing special. Really nothing special. Unless these are counterfeit parts and something's wrong with them. That would be very annoying. TL074C, that should be just like the normal ones. So let's go to ohms on the multimeter. I'm going to start poking around and seeing what could possibly have happened here. So suspect number 1, power supply to the connector. So the connector comes across 2 of these. So if this here is connected to this here, 5 mega ohms, so no. This here connected to this here, 4 mega ohms. Ground to that pin. That one might actually just be connected to ground anyway, but 300K. And then this one, I don't think interferes at all. 500K. Half an M. That makes more sense. 0.4, but that's the ground pin. You can see the little ground connections on it. So that makes sense. That's fine. That's the way it should be. Let's see. What vias do I have under components? Under components, do we have anything that could possibly cause a short circuit if my component is installed weird? Not really. Those look good. Yeah, those look good. There was one that was a little close up here. What's this one? That one to ground. Those should be okay. Even though there's a chip sitting on top of them. Like, I don't think there's any fundamental... It would be like if there was an excess of solder on any of them and they happen to, like, hit the other pin. The LEDs are probably most guilty of that. Let's bring the top layer back in. Keep the board flipped. I don't need it to be unflipped. But these get kind of close to stuff. But they appear to be working. I mean, we've tested that with a multimeter. Let's see. There's the chef's hat. That one, yeah, kind of, it's got a little keep out area around it. That should be fine. I mean, we don't see a short in the power supply between negative and positive, do we? We didn't even see that big of a current jump. It just kind of immediately buzzed out my power supply on the tester. But that indicates that something is wrong, and the tester's trying to save us from ourselves. Yeah, 500 kilo ohms, that's enough resistance to kind of represent a couple TL074s. In reverse, it says overload because there's voltages present that I've charged accidentally. By connecting my multimeter, I'm putting a little charge into things. Okay, well, I'm gonna find out what's wrong with this thing. It's, for some reason, not powering up at all. It's overcurrenting. There's an inrush. I don't really have stuff to prevent inrushes, but it should be okay with inrushing a little bit. I wonder what's going on. Without any overt shorts, it is a bit of a mystery. Could... Well, no, I don't think so. Having the circuit connected with all this stuff should be fine. I don't think the input is grounded, and I don't think that would cause an inrush. It does go positive immediately, but these are kind of floating at first. I don't know if I need to have a 100 kilo ohm on that to ground. I don't know where I'd implement that. It's kind of a tough one. I have to look somewhere on the circuit that I can install it. I'm using a new chip. I didn't use the old one. That's sitting somewhere on the desk, is it? Wait. Yeah, it's right here. Yeah, I've got the old one right here. We didn't trust the one that was reverse. But it might, you know, it might be good, it might be bad. I'm going to test that independently. I'll put it on a little breakout. Ow! This heavy steel plate makes it so that I can't observe my board as easily. We can slide around like this, but I wanted to look at it from the side. I guess these are okay. I just don't like how crooked they are. They're just a little bit weird. Like, I don't know. I mean, I gave everything a lot of room on this design. It shouldn't be shorting anything. It shouldn't. The TL074 should not be capable of drawing enough current to sort of weird out my power supply so easily. Unless the tantalum caps like took a shit, but I don't think everything looks good. I really don't see anything. Let's test. Hold on. Let's test input to ground. So initial input here, ground here. 1 mega ohm. So that would be the resistance of the two, the LED part of the circuit. Which makes sense. So 1 meg, that's fine. Although it should be 2, shouldn't it? It should be 2. That's because of this down here. These are supposed to each be 1M. Did I put 500K in there by accident? I don't think it'd matter if there's 500, because it's still a giant resistance. It's an enormous amount of resistance. I am befuddled, chat. I don't know where the problem would be in this circuit. What if I plug in an input and power it up? I get rid of my little, or just plug anything in and power it up. Well, actually, we'll just do an input. I'll do just an inert plug just to open up that switch. So open up the switch like that. And so that'll just open it up. Yeah, we didn't get smoke. It didn't have the courtesy to at least smoke for us. First of all, does this power up on its own? Yes. Okay, so that works when we have nothing powered up. Stripe is here. Stripe is there. Stripe is everywhere. That. So double check stripe, plus, power. It doesn't power up. It's doing the same thing where it like tries and then dies. Whoa, 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 whoa. Oh, we blew a tantalum. We're not immune, chat. We are not immune to propaganda. What just blew up? Was it the tantalums? Yep, buddy boy right there on the right. The death of a tantalum capacitor. Does that actually mark negative? Positive to ground through the tantalum. You know, we got the smoke smell and everything, but we didn't get the courtesy of having this thing actually blow up. It didn't blow up. And the merit indeed. Tabernacle. Okay. Well, let's get these things out of here because they're cancer. They suck. They're so bad. Tantalum capacitors, ladies and gentlemen. I could have sworn, because we looked up tantalum capacitor markings, and positive is in fact the stripe, is my understanding. Wait, does that say 225V, but it's 35 volts? That might be 5 volts. I think I put 5 volt tantalums in this. we thought they were 35 volts, chat. It said 35 volts on the bin, but I think these are 5 volt tantalum capacitors. I don't think they're right. I don't think they're right. I don't think they're right. We need to get these out of here. These are wrong. These are so wrong. These should have blown up. These should have been a nice clippable explosion, but nope. We're not lucky enough. All right, I'm putting a little flux on this so I can get them out of here. Open the door. Open the doors. Get them out of there. What do you want? Can we have some kind of a peace? Peace. No peace. What do you want us to do? Die. Okay. I don't know why Independence Day, I quote it so much. Everybody's tired of you quoting Independence Day, Father. No peace. Shut up. Shut up. Shut up. Did you look up tantalum capacitor markings 2013? No, it's not the markings. These are 5 volts. That is not in spec. These are 5 volt tantalums. I didn't look at the markings on them. I just assumed that the piece of paper that told me what they were was accurate, and boy howdy is it not. This is another method of desoldering components, or removing components rather, and that's adding a big lump of solder, because that big lump of solder is going to take longer to cool down, and so we can jump from pin to pin faster, and that allows me to move the component while the solder is molten. Liquid metal. Your parents are already dead. That's liquid metal. Okay, so those blowed up. Oh yeah, look at that. There's the blowed up part of the tantalum. That black spot on the side is where it started to cook the outer material. It didn't do us the courtesy of exploding because I've got current limitations on the power supply itself that I built. I used a little USB-C 15 volt regulator to go into my other regulators, and because I bought this all from Pololu, most of the power supplies, the negative 12 volt I bought off of eBay, but the Pololu power supplies are really nice luxury robotics power supplies. They have a lot of really cool stuff. Michael Minogue. Apparently boredom is the new unobtainable luxury. Yeah, that's being in your 20s to 40s. Welcome to the modern world. Boredom is important for creatives, and I am of a mind that electrical engineers are creatives, but a lot of employers do not believe that. But boredom is what spawns innovation. Spurs innovation, maybe. You want to put the spurs to innovation, bore people. 6 volts, 10 volts. So the ones that we were trying to put in, 35 volt type B 225. There's a 16 volt 225, a 10 volt 226. Let's try to find those 30 volt 225s, huh? We can do a little forensics here. Maybe it wasn't my fault. Here's the 105. Sheesh. Eventually my brain will catch up with us. Here's a 16 volt 225. This one might work, but it's also possible that it'll blow up. Boredom and laziness, yeah, the two primary elements of innovation. Keep putting that I'm lazy on my resume, but nobody's buying it. Nobody's really biting. Where's the one that I installed? One of these should be missing 2 caps and should be huge. Is it out on the desk? Where? Hold on. Hold on. Why is there a knife on the desk? Just sitting. That's how you hurt yourself. Okay, we've been kind of a blast radius for a little bit here when working on stuff like this, because you sort of move from thing to thing to thing so quickly that it ends up becoming a problem. I don't see that thing of, I thought I got them all back into here, but none of them are missing components. And oh, this one is 35 volt 225. Smoking gun. It's not my fault, although it is my fault for not reading the top of the cap. 35225V. 35 volt. No, 5 volt. That's what my job was supposed to be at that medical design company. I was gonna try to automate some stuff in their workflows so that they could have, you know, better workflows going forward. But apparently they didn't want that. Okay, so maybe the voltage isn't really actually explicitly written on this. 227J. So we actually have to look up. So that's not a voltage. We have to look up 225V 024R2. This is why I hate tantalum capacitors, man. Hold on, before I change cameras, I'm going to look up that number. It's not my fault. 225V 024K2. Damn it. I always wonder what I'm doing when other streamers might pop in to see what I do on my stream. Tantalum capacitor. Come on. Come on. Come on. What is this? Oh, I'm gonna open up generic 2.2 microfarad, 16 volt, 25 volt, 35 volt, 16 volt, 10 volt. Yeah, this is not unified. Why is it? This is what I hate about these tantalum capacitors, is that you can't just look up the number on top of it. Tantalum capacitor markings. We're back to this. All these wires are in my keyboard. I hate it. Get out of my keyboard, wires. Lazy is to not repeat yourself, but it leads you constantly to find ways to automate things, which ends up usually into making more effort than repeating the same task initially. That is a mouthful of a sentence for sure. Like a spiraling sentence. I need to replace the following cap. Okay. There we go. Polarity indicator, picofarad code, so 225 would be the picofarad code. Rated voltage, that's not on, and K is, they cross it out. And then a date code. A messy kid is a busy kid, I suppose so. 225V 024 K2. K2, that's just, is that just the manufacturer? No, not really. It's not a Chemet. I don't know who makes these, but Chemet has their own manufacturing codes. This isn't gonna load. Yeah, that's not how ours is organized. And we didn't even see a printed voltage on this thing. I don't know what that little like nudge is right there with that thing. But we've got 225V. I wonder if it's 2.2, and then the 5V is 5 volts. In which case it's not my fault. But this isn't like a unified code, so it's not really helping us out. 024, 2024 maybe? And then K2 is the K code or whatever? I don't know, guys. I don't know if it's my fault or not. So let's find a capacitor that will work there, or I just don't put one in, and we can just roll with that. I could put electrolytics down there. They wouldn't get in the way of anything. They just be the initial target of any kind of physical harm that comes to, you know, it's going to brush up against stuff, possibly. I would be comfortable with 50 volts, but I want more than an UF. I probably want a 4.7. It would be nice to be able to go to 47, but I think, like, you know, 35 volt 10 UF, that's way too big. That's not going to fit in that pad. So we're down here with the tiny ones. So I guess we should try 50 volt 4.7 like we had before, that we could barely install. $10 UF, 25 volt. Maybe at a pinch, but I don't. Oh, that's right. Horizontally, they don't want to fit, because that only goes like this far over. Yeah, see, and then there's a big block there. So actually, we can't fit these. I need to spread these out a little bit more if they were to fit in. Yeah, that is tough. Okay. You look tough. I need to take a picture. Capacitors, man, I'll tell you something. The tantalum capacitors are there to deal with a sudden load and to make sure that we don't dip down in voltage to the rest of the circuit and cause noise. So if I can put 47525 or 35225 is what we were looking for, but anything that's got a significant 25 is going to be a little tight, but I'll accept it. So this one is apparently not 35, so I don't know how much I can trust any of these others. This one's 35105, so that's going to be one off. Ugh. V. So again, the last digit is a 5. How do I know that that's 35 volts? Because we blew up the other ones, and the other ones weren't even doing anything. Let's just leave the caps out for now. This is a big capacitor annoyance that's going on. We'll leave the caps out. I'm going to leave out the caps. We know they're needed, but we'll see if this thing works first, and then we can play around with all these weird capacitors that I have. I think this is just going to solve the issue that we were having, and I think this will probably just come right up into power. So we make sure, again, we're going to check every single time because of the number of the number of circuits that get sent to me that are dead because this was plugged in wrong. I'm always checking stripe. Stripe there. Good. Is the polarity correct? I checked like 3 times. The stripe is plus. And so the ones that I had in here, double check, because that is something that I do get wrong every now and then when my head's not on a swivel. So we can probably rewind the stream in order to find how I exactly installed them. But hold on, let me push this up a little bit. Oh, jeez, I gotta put felt pads under this block of steel if I'm gonna be using it in the future. Negative comes in through this diode, goes over to this one on the left. I had this one in this orientation. Ground is more positive than negative 12. The other one I had in the opposite orientation. I had the positive here because positive comes in here and goes over and it dips onto that capacitor and goes out to the rest of the circuit as well. And the tantalum's stripe is positive. So I had the positive facing this direction. So I think I got it right. I don't know why it exploded on me. I feel like these maybe are 5 volt tants, but this one has got that signature tantalum hole in it, and the side is all blowed up. Oh no, this one just has a hole in it. This is the one that blowed up. Big old scorchy spot. I don't know, or these are knockoffs or something. I don't know. I feel like that 5V is 5 volts, but maybe it's not. I don't know. It could be some other code. Yeah. Yep, line on positive. I was making sure of that. We looked it up twice. Sons of bitches. Okay, so let's power this thing up and now it'll work and not have any controversy at all. So like this, I'm plugging it in so that the plug is on the outside because we want to be able to see all this stuff. And then I'm turning this on and there will be no controversy. No controversy. The green LEDs are illuminated slightly, probably from electronic noise, 60 hertz noise coming in through here. If I give it a sine wave, we have positive and negative illumination on the LEDs. And if we check our signal through the scope, by the way, we are drawing very little current. That's good. And so we got, oh, where's our scope? There we go. We have a plus minus sine wave, a little bit above 6 or 4 volts. That's should be a 5 volt amplitude sine wave. Powered MULT. It's not a difficult circuit. This won't cause anything to happen except that this one should probably have gone blank. Why is this one? What the? What? Did I? What did I? Wait a minute. Uh-oh. 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 Uh-oh, Spaghetti-O. What did I do? Did I somehow flip the amplifiers? Oh. Oh. This one just doesn't work. Most of them are good. No signal. Then, wait, yeah, this one. I think it's a sine wave, but then this one should also be getting a sine wave. Which it does. But then if I go sine here, and then I give this one, which signals work? Let's give this one a 2 volt DC. Which is displaying on the wrong, oh no. I got some pins wrong. Oh, son of a bitch. Oh no. It's reversed. This is now going to this bank. This is going to this bank. Ay, ay, ay. That's... How did I do that? How did I do that? Is that a fail state? What do I do with that? I don't know how to correct that. I don't know how to correct that. There's a... There's a bank issue going on here. Son of a bitch. What? What? That also is going to create like little bits of noise too, because that signal is going all the way up to here instead of just being cut. That is hilarious. I can't believe I did that. Ow. Was that just pointy? That was just pointy. So the square wave on this pin here, or rather the sustained DC 2 volts. Why is it doing that? It's because of the way I connected the switches. I did it wrong. I don't know. When this one is connected, it cuts off and it goes, oh yeah, that's the wrong way. This is completely, I did it wrong in the schematic. This is not what should have been there. I can't believe I did that. How do I correct that? Okay, let's think about this. How do I correct this? Because when this connects, it should be going to this one instead. It should be going to the second bank. I treated the banks wrong and I mixed them up. What's up, Bombacade? Bombacade. How can I correct this? If I swap these two, that will correct it. No. If I send See, when you, well, no, but when you plug this in, P2 disconnects and P3 is the tip. So yeah, J1 and J5 need to swap. But if I can't do that, how can I do that wiringly? P2 is the disconnect that should be connected to J5. So if I can flip 2 of the pins, so that's J1 and J5. And we're kind of restricted with our pins here. So that's this connector here, and it's between 2 and 3. So this line and this line, that line goes to here. This line goes to here. They're right adjacent to one another too. So that one goes off in one direction. Oh my God, this is a nightmare. This is a nightmare. This is a nightmare. If I flip the connector and somehow get the ground pin in there, then that's not going to solve it, is it? Well, somehow getting ground in there is kind of a problem. Flipping the connector over, I don't think that solves it. Let's see. I mean, yeah, I can cut the trace, but flipping it isn't the problem. It's which one of these connects. But that means that if I flip this, then P3 is, yeah, that is flipping the pins. If I flip over the connector, that could be fine. And then I just attach the pin somehow. Like attach ground to the one adjacent to it. So I remove these and I flip them over, and then it'll work properly. Man, that is annoying. I can't believe I made that mistake. And it's right here. If I just had thought about it for 5 seconds, this problem wouldn't be a problem. But I didn't think P3 on J5 should not go to this bank. And if it does, then I should reverse the position of these two. I didn't look at my J's and my R's and stuff, because this is the second bank, and that should have been connected to the second connector that I put in. So big problems, huh? Now I could correct it in this design. I've already ordered 10 of these for $75, so I am going to make this correction in situ, and I guess I can do it just by reversing this top one and connecting its ground pin to this ground pin. I don't think I can really double up the ground pins, but I can definitely get that one to connect properly like that. Desoldering a Thonky Kong in this setup is not going to be easy. How am I going to do that? If I run hot air, then everybody gets hot, and I risk melting connectors. So I think I got to do it on an individual pin basis, in which case we need to rock this back and forth as we heat up the things. Because that's a better solution than just, removing... Sorry. Better solution than cutting traces. Wait, but that's not, no, that's not connected to ground. No. That does something on the other layer of the board. Yeah. That's so annoying. Okay, all right. Well, time to get to work. See, what I'm doing is I'm just putting force on the side of it and then heating up the pin. Ow, that's hot. See, that one works immediately because these two pivot quite a bit. But now these two need to be heated at the same time, sort of. Not using microscope on this. I think I'm putting too much force in it. I'm bending the whole thing. That is the most comical solution that I think or most comical problem that I think I've had with this stuff. My magical reversing connection, and it was right there, laid bare in the schematic for us to discover. I shoulda, coulda, woulda known. Shoulda known, shoulda known. All right, out. So this one. Whoa, geez. It suddenly moved a whole lot. It's actually pretty easy to desolder. It's nice. That's pretty nice, just bending it like that. Okay, so let's clean up the pads, and then we'll have to cut the ground lead on these so that there's enough ground lead left that we can actually, I need to get a better grip on this thing, that we can, enough ground lead left that we can solder it to the one adjacent. And that'll solve all of our problems forever, and I'm never going to have to correct this, not even once. I will probably need to correct it at some point. Reverse the two. Hopefully that doesn't cause a huge issue. It probably will cause huge issues with how I've run the traces. But I don't suspect I'm going to need 10 powered mults in the future unless, you know, John's synthesizer breaks down my door and goes, "Bother, I need you to manufacture that design for $1 million." But we're not going to make $1 million selling mults. That's just not, that's not a capability of the universe. Asmer, solder braid, stream, 375 viewers. My $1 million mult scheme. The word mult is just made up by the synthesizer people, just so they could say multi-tap without sounding like nerds. Hey, that desolders nicely. Of course, it helps that we're bathed in flux right now. Not quite. It's not really no, multiplex is still nerd speak. It's multi-tap. It's a multi because it's not, well, I guess it is multi, but a multiplexer you would assume has some degree of being able to route the signal, which this doesn't. Like I would expect a multiplexer to have like a control on it, which would be kind of cool. I could build that today. I have that Maxim switches. Those are the like plus minus 15 volt switches. Oh, ad break in 2 minutes, everybody. So for those that are going on the ad break, you won't be able to see what I'm doing. What I'm going to do is use the same connectors, but I'm going to cut the ground pin so that the ground pin can bridge to the connector next to it. Because this pin right here is a ground pin. So all we need to do is take this and extend it flat and then cut it. Copper braid is unfortunately one use. In video, we call them distribution amplifiers. So that's a better, yeah, that would be a better way to refer to it. The copper braid is not reusable, although sometimes you can get away with using it for like high current traces. And that's usually typically where I'll, you know, use extra of this stuff. Oh, we might have another problem, is that this might not be centered anymore when we reverse it. So let's just try it on one and see if we can get it right. And see if the top still goes on. These are a little bit asymmetrical. Oh my God, every time I talk, I hear Willow roar roar. And that's all I can hear. She's yelling at something out there. Looks good, but let's see. Oh, there it is. Yeah, and desoldering braid is kind of expensive too. So, yeah, look at that, son of a bitch. Can I get this to like offset itself a little bit? No, of course not. Damn it. So that doesn't work. We've got 1 minute left until the ad starts. God, those ad breaks take forever to initiate. So reversing it will work for me, but not for them. Damn it. Gonna need a doctor, but not for me. Okay. So that won't work. So then where are my traces going? Gotta look at the traces now. I can't believe this. Is this gonna cause me to order new boards? I don't know. I don't know. Yeah, see, those kind of sneak around each other. And in this case, I would be able to fix that immediately. That's an easy fix. All I need to do is knock out this and this, and then just run this here and this up here, and probably with wire, and I think I can avoid the connector if I run it around the periphery. We got to make sure that every single problem here is corrected though. If I delete these, it might delete the traces. How about the other one? Let's check the other one. And we've gone to commercial. The other one is J5, the one with the LEDs on it. So it's this one. And the connector comes from below. And this is a nice big clear area. So this would run right to here. And then this one, we would just run out to here. Bitch lasagna. So I'd be able to move that and just run it straight over to this, which is the same connection. That's where it goes above. I probably could move those out of the way a little bit. Where else is that one going? That one's coming from there. There's probably some more clever things that I could do with it. Like bump these two over. No, because then I need to jump around there. So that's, yeah. Okay. Or I could just have a via here, but then no, it's not. That ain't it, bother. That ain't it. At least it makes this one a little bit, it'll be larger ground planes in this area. Yeah, I could go through JLC. I wanted to do Seed Studio, and it turns out that I had to pay $20 in tariffs. So the 10 boards for $10 had $27 in shipping, and then also a $20 tariff attached to it as well. So I got hosed in tariffs. I didn't expect that, because in previous orders, and you know, tariffs are like, are they going to be there or not? Who knows? And so I just kind of got destroyed by it. I wanted to try Seed Studio because I figured that the dust had settled, and instead of the dust settling in the way that I thought it did, the dust actually created new and unique fees. Good times. This is an easily correctable thing in terms of the design of the board. I mean, I could literally do it right now. But in terms of what I need to do to correct it, I would have to cut that, and then I could go from the via to there. I would have to, I guess I'd have to do these corrections on the bottom side of the board, since the top is where all of the connectors are, because those will get in the way. There's a big plastic body. Although if I did just like a motor wire, I could, well, no, because I can't pick this up anywhere but here, which is outside of the connector. And if I did a little motor wire, I could maybe melt it into the connector a little bit to get the motor wire to be on this layer, and then connect it over to this pin. Might be a little hard to do, actually. What the? Oh, we're back from the ad. Welcome back, everybody. I'm discussing ways that I could potentially correct this physically, and also in the design, they're going to be very easy to correct. So let's do the design correction now. So I think I'll save off a copy of this before I forget what I've done. Actually, you know what? Instead of correcting it, I'm going to put text over here to correct it. So if I decide to re-roll this board, I will know what I need to correct. But we're not going to alter this because we're using this as a map of what's there already. It looks like what I'll be able to do is use my little trace cutter and cut this here and solder to this via. And then for this one, I'm going to have to go for the top of the board, and I can just sever this pretty easily. That one is coming from far, far away. So that one I'm going to have to unearth the trace a little bit and go from there. I can't reverse them, by the way, because we tried to reverse one, and it's not, these connectors are not symmetrical. And so it might look okay like this, right? Kind of looks okay. But then when I try to put my cover on them, it doesn't fit because this is just off by a little bit. The tariffs are weird. Last time I ordered from JLB, the tariff was for like $1 for larger boards. Time before it was $5. Ridiculous. I don't want to print a new cover because they're supposed to be evenly spaced, according to me. I don't want to go down the road of you know, huge modifications. I'd rather have all of my connectors be in the same way that they're supposed to be, but connect properly. And I don't really have room on the sides of the board to run tiny wires. I guess I could run them here, but everything's so small. I don't know. Maybe I am kind of in a position where I'm going to make the connection, make the correction digitally, and then just order another stack of boards. That's so expensive, though. Just doing this so I can give my friends a couple boards. What's the modification going to be like? I mean, those are the two that I need to reverse. One of them going down, the other one going over and down. Oh, that's so annoying. And I can't even sell that as a feature. So that trace would go there, which is not that hard to get. That trace would have to go there. I could just as easily bridge between those two if that's what that is doing. This one would be the tough one because I don't have anything to pick up on. And it goes down this way on the very edge of the board. So if I solder something to it, well, if I go inside, but if I go inside there, then I'm running into the internal structure of this, which has a bit of an issue. I might just order boards again. I hate to do it. It is a really minor correction too. Or I sever it and I just run wires from here all the way up to here to make that correction for now. So we go from the chip, which is the end point of both of these, we go up. We go directly from there to there. And over here we go directly from, oh wait, no, we can't do that because one of them runs all the way to the other connector. That's not how that works. Ugh, hold on a second. We can highlight an entire signal. So like if I highlight that, miter, move, name, find on board. Yeah, look at where this all goes. Down to here, up to there. Actually, that might be a good place to get it. So cut these, go from via to there. That's instantly doable. Okay, I'm feeling a little better about this. Because that does the correction, and then this one also needs to be reversed. So that one we can cut anywhere around here. We don't have a good via in the area to pick up on. So this is the tough one, where we're on the top layer of the board, and I need to scrape the trace somewhere to expose it and put a very small wire on it and get it to go to here. And there's a via right there. That's going to make it even harder for me to solder. This one cut on the bottom of the board, and then we got to take a look at that other signal and see what needs to be done. All right, first things first, sever this, attach it to this. Might be easier than we think. It's a chef's hat. See, chef's hat. Kind of got, it's only 3. Cool, 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 cool. All right. Yeah, what problems I've made for myself. Oh, woe is me. All right. Sever that. Step 1. Let me get the knife. My knife. Proper. Okay. I could use the tile cutter that I got to do that, but I think these are too small for the tile cutter. The tile cutter can be kind of a force of nature. It creates a nice little V groove, but I don't want to damage anybody else. So I think what I'm going to try to do is just take a score line. Is anybody over here? No. Okay, so I've got a little bit of immunity if I go here and I just sever this like this. It's hard to pick up on what I'm doing. Need like more magnification. We could get closer. It just doesn't feel like I'm actually cutting the board. There we go. That feels a little better. And then we'll take a gap and go right here. And then flat against the board. And we'll basically just sever the trace down to the substrate. Scrape it a little bit from without the blade. Scrape it a little bit with the blade. The goal is to get a nice big gap in that signal. Cut towards yourself in a jerking sort of unpredictable motion. Just want to make sure that's not shorting out there. Unfortunately, this is going to create a little bit of madness. I'm kind of putting an antenna onto my circuit right now. But I'm not going to correct all 10 of them like this. Oh, man, I can't believe I made this mistake, you know? Okay, so now we see whether or not this connects to wherever this goes, which would be the via that's right here. Which one is it? It's... Oh, I see. It's way down there. It's actually under... No, that's between. Those are between. And so it's actually this one. What? No. Oh, no, it's over. Sorry. The board's mirrored. It's this one right here is where I want to check. So multimeter. This is why I don't cover over the vias. This is why I have a solder mask around the vias, because we use them. It's really going to cost another $75, another tariff fee. Unless the tariffs suddenly change, because China said something stupid, and our little whiny president decides to put 9 million billion% tariffs up because he's a giant baby. They were mean to me. I'm gonna do something. Sure you are, bud. Sure you are. Okay, disconnected. So that one's disconnected. The other one I need to also disconnect, but if I do it close to this, I can just have a tiny little jumper right there. So what I'll do, actually my probing of that via kind of distorted it a little bit, but I can just put a little line right here and I'll cut off over here. This is the part where we just make it work. That's our only goal, is just make it work. The problem is I need to connect this to here. So we'll have to look at where this one goes and see if we can pick up on it on the other side of the board. It'd be easier to scrape it from the edge. Oh no, it goes down. Yeah, that's right, it goes that way. So yeah, I'll go this way. There we go. I think that severed it completely. Hopefully we're not creating a ground fault in that. Let's check between this pin and wherever it goes. Let's take a look at the trace. Highlight. What was that again? It was find in board. All right, so that's the one we cut right about here. It also goes to that dot there. I'm gonna have to reverse these still. So this one's actually supposed to go to here. And it goes to this as well. So we'll be able to get this from here to there, but I don't have anything up here that it connects to. So that's going to have to go all the way up to this. And again, it would be trivial for me to do this in CAD. CAD is it's super trivial for me to reverse the two. But here in the physical world, it's a little bit more difficult. I don't have any vias until we get all the way down to this part of the board down here. It would have helped me if I did that, but I didn't expect to get it wrong. I expected things to go perfect. Is this really where I would have to reverse them, or could I have reversed them elsewhere? Did I make a mistake cutting that? If I kept that one connected to that same pin down here, no, because those also need to be reversed, right? So that doesn't help me. I'm tempted to just do the correction, because we saw complete working board. We saw it working, if not just a little briefly. It's like the temptation is to not do the correction now and just do it digitally and order more boards, and then next week I can build up another one of these and it'll work. It's almost easier. But I preach that you need to get it working at this stage. That's your one job. Oh, and I already cut the board, so I had this one. Damn it. I was thinking I could reverse it and test it and just not put the front panel on and then do the correction digitally, and then we order new boards. I should have done that before I cut the traces, huh? Can I still correct these? I might be able to. I'll just scrape them. That's so close to the via, though. That's going to be so hard to solder. This might be a rage quit from Oh Bother. And then we'll come back tomorrow and we can work on. I might be able to actually correct this, put this back to where it was, and we'll reverse the connector and then see if that solves the problem, which I think I think it's going to solve the problem. That's pretty clear. But yours truly is starting to get a little pissed off at his own idiocy of not the one little thing that I didn't check over. You know, that little detail I didn't check over, the whole will it work thing. Where does this specifically go? What are these vias right in the? I've got a ground via that's just right there. And then this is where the other signal dips down to get over to the other side. Yeah, the one little detail that cost me $70. Can't beat myself up over it, but I am a professional at that. Yeah, okay, let's see here. Let's see what I can do. Just load this thing up with heat and just transfer all the components over to the other board. At least this is entertaining to watch. I just went back on my own decision to reverse them in place because it's going to be a little bit difficult to do. And so now I've got to see whether or not I can fix the traces that I just ripped up using the knife. And it doesn't matter if those get solder on them. Actually, this one might. That one might be thick enough that it actually pokes to the other side of the board. Or sorry, pokes through to the connector right here. Shorts it out. All right, so those two are exposed for their lies. Now we need a piece of motor wire that I completely strip of its coating and get to solder because we need such a small piece of it. So can I just treat the end here by wiping it with the iron? Flip it. You guys can't really see what I'm doing. I can't really see what I'm doing. I'm just rubbing the iron on the end of this little piece of motor wire because this is incredibly small, and it's possible that we can get that in position and get it to solder down to this very, very small trace. Everything is so tiny. I can't see it. Oh, because I'm not holding it. Can't see anything. Okay, the posts are getting in the way. If I could just turn back to right when I was making the decision to cut these and tell myself, bother, stop. You're ruining everything. Actually, I could just use the motor wire to go from there to there. What's up, Unethical? How you doing? Weekend marathon? No, we got, so in lieu of my design mistake, I can just move on to the other modules that I want to build. I'm good. We have a very basic mistake that I made here. I made a very basic mistake. Let me use the file here to kind of strip this of its stuff. And so we're making a very small correction. I'm going to move to the needle tip because I think that'll facilitate soldering this a little bit better. Do the short needle. We don't need a long needle. Made a mistake. I made two mistakes, actually. The first mistake was I have the schematic wrong. So that went all the way to the design. And I, of course, can correct that easily in CAD. But these were expensive. These were $75 for all these boards. So I can correct with motor wire. I'm not going to do that for 10 boards, though. You know, that whole time is money gig, that applies here. And so correcting this now just to test is important, even though we saw this working. No, that's just not going to do it. Motor wire is kind of finicky. I don't like working with it. The shellac that's on the outside of the motor wire is very solid stuff. It's hard to get off because these motors are supposed to be able to go through some pretty freaky abuse. And while I am adept at small soldering, yeah, see, the motor wire is just going to do whatever it wants, and I don't have the depth of field to see where it is. We're still getting used to these board holders. They're a little tall, just like that. And if I go over to here, I'm going to need to move this clamp. That'll get us out to like here, a little further actually. I gotta watch how much I bend this because it'll break off of its pad. Let's go out to there. How am I gonna cut this? Hold on. well, if I can get this to maneuver, but there's that, the vise is right in the way, the thing that's holding up the board. Deftly maneuvers and muscles for rank. Fuel burning fast on an empty tank. Okay. Hey, wait, Monster Truck Force. In his mind, he's still driving, still making the grade. She's hoping in time that her memory will fade. I could have gone... Could I have gone, like, directly to that? Wait a minute. Wait, hold on, wait, this has got to think for brain, 1 sec. Brain, what's going on? I think I actually could just go right there, and that would make the connection. Hold on a second. Wait a minute. Wait. Because actually, what we're looking at... Okay, what the hell is that? I hit F and it went to that scene. This looks like this, IRL. So this via right here goes to all this stuff. So actually, we can connect here to here, and then we're going to need to pick up on something else to get it up to there. So we need to pick this. Yeah, so this has to go all the way up to this pin, because it doesn't drop to the other side of the board anywhere. I can't get it anywhere else, so press F to pay respect. Yeah, there was no respect in that maneuver. So yeah, I do have to do what I'm doing right now. And I think what I want to do is just drop this into this pad right here. And you know what, it doesn't need to have that 90 degree in it. It can just like organically go from place to place. But what I'll do is I'll drop this down in there. Did you design the current PCB? Yeah, this is my design. I have all the files right here. Yeah, and I put a chef's hat on there. What is going on? This stuff, just turbo super duper annoying. So I can basically go from here to here with a little piece of wire. And then this, I can drop in here and that'll reverse this one. The other one, it's going to be a little harder to reverse, but we'll figure it out. Yeah, I got my work cut out for me. I'm starting to think that fiddling around like this is maybe not worth it, and I should just do the correction in CAD and order another board. Yeah, it's what I'm trying to do is turn this down for I don't know what, but turn it down so that I can throw it into that other hole and have it in parallel. And then when I'm soldering it, I can just kind of harass it to make a contact there. And that'll reverse these two with maximum effort. That's a lot of effort to go through for correcting this. And then, you know, future I could like hold it down with ultraviolet glue. But I think what I want to do is just make the correction in CAD and just order more boards. Screw it, you know? Just order more boards. So theoretically, that would correct that. And then if I get that soldered, I would just scooch this to the side a little bit because that would clear the FonkyCon connector. Weekend marathon. I have other stuff. I have other stuff to correct, or to build rather. We have other things to build. I could do a second wire that would go there, but the effort to do that is getting really annoying. Yeah, we'll do more. You know, I'm going to do a stream tomorrow and possibly the day after. I don't know. I don't know if I'll do Sunday. I don't think I'll do Sunday. I might. But if I practice, I really should practice what I preach and actually do the correction on this thing. That would mean I solder from there, from that via to the connector, which I could do that on this side and it would be a little bit easier where the chef's hat is. Didn't come through as clearly as I wanted it to, but it is, you know, it's a chef's hat. But if I go from either the via or from the resistor to this one, then that one will have been reversed. So let's get a connector in there. Don't know if I want to reuse this one. Yeah, we can get the old connector in there. That should be fine. Get the old connector in there. Motor wire is very finicky to use because it's very difficult to strip the end. Okay, and then holding the board is kind of a challenge when you've got these thonky cons there and your board holder is huge. Put the iron away when I do this stuff, otherwise I'm going to hurt myself. The wire of wax coated, not enamel. Iron melted wax shorted the power rails to ground. Whoa. I mean, it must have been spectacular, but at the same time, that's horrible. Yeah, motor enamel is very serious stuff. It does not like to be displaced. And it's very difficult. A lot of people use like a lighter to do it. I use mechanical means to scrape it off. And after that, the motor wire should then connect. Now I have my doubts with this setup because I've simply inserted the motor wire alongside of this. So I don't know if we will create a good contact there. I can apply solder and I can hold the solder there, but I don't know if it's going to be effective. It's an untried method. In the past, what I would have done is scraped the wire a couple times. The end of the wire won't have anything on it, so I might be able to get a connection through that with it being embedded in solder. Oh no, it's actually right there. Oh, interesting. Yeah, sandpaper is the best way to do it. Let's just redo that one. I'll get the ground too. Now we hold solder onto this for a little bit. So hopefully that little end of wire will make a good connection. Now we're picking up on it here, which goes to here. So I need from there to there. I'm going to go ahead with this correction. We're going to do this. I need to practice what I preach, and so I've done this to myself. I typically like to use a file to actually scrape off the little bit of enamel. I don't know if that's super effective, but it's worked for me in the past. Just a little bit of pressure, a little bit of file, and then I need to kind of like roll around with the end of the wire on that. Well, that's not a wire wrap opportunity. I wouldn't have been able to wire wrap that at all. Now, if I had like a syringe with this wire inside of it, maybe. But wire wrap is specifically for square post pins. Square pins, because it creates a really good connection on those corners where it kind of crushes the metal down a little bit. Okay, so that's soldered, but the steel is sapping away all of my... this is a steel plate because I'm using magnetic board holders. I have been on a wire wrap binge. Well, I'm glad, hey, I'm glad these techniques can help people out because we haven't really been wire wrapping stuff since like the 70s, but it really helps when you're doing, you know, undergrad labs and stuff. If you need to make a really good connection to something that you've just got test leads on like a breakout board, it makes a really nice connection. And I don't know why we've forgotten about wire wrapping. I guess the other methods have just kind of overtaken it. But it makes a nice, like a really good connection. If you have to dive into your design a couple times and like make corrections and stuff, it'll hold up to all of your various machinations and, you know, moving stuff around, and this gotta go there now. What's going on? Why am I not getting heat into the pencil iron is a little bit more unwieldy it cools off way faster. Adding a lot of solder to the ThonkyCon typically will have the solder on the other side get larger and larger. So you got to be careful not to do an excess of solder on these connectors. That feels like a cold weld, but I'm going to accept it into my heart. Now, if I had the authority to turn that down and insert into the via, I would, but I don't. So I'm just going to take the end here, barely even push down to do that, and just do a little scrapey scrape on the end. Hopefully that's enough to convince it. Who is Vince, and why are we always trying to con him into stuff? I kind of felt like it made a connection, but now it's like lifted above. Actually, I think that might be good. All right, so let's see here. So from that resistor, here to this over here, 0.8. From this all the way down to, where can I pick up on that? Hold on. That one currently goes, how do I, no, right click, can I highlight? Hold on. Oh, that's not the one that I want anyway. Where is it? No. I want the top one, which is now connected to this one. Polygon, dimension, analyze signal. No. We don't want to, no AI. No. All right, well, that one goes all the way down, diggity down to this via that is right below the LEDs. So that is all the way down to, where are the LEDs? Like around here. I'm never going to be able to find that. It actually, I think it goes to one of these. No? Okay, hold on. Let's pick up on this. It goes to, well, it goes to the top connector of the one it's not supposed to. So actually that's this right here. So this, all the way to this. I'm getting 10 mega ohms. Oh, with the connector in there, it's actually connected to all kinds of stuff it's not supposed to be. So maybe that's not just not coming through right. I'm getting a mega ohm. So that probably means that it's not actually connecting to where it should. What a, oh man, this just mad. This, oh, I might have been measuring it to the wrong thing. Hold on, that to here. Ohms. Oh, okay, so it is connecting. Okay, good. Okay, now we can do the other one. So now we go down here, and we got this one here. So if I can get both of these things to hold on to this a little better, we might be coming out of this all right in the end. We might make it, chat. We might just make it after all. So we've got to reverse these two. And one of them is only on the top board. And that's this one here, coming around all of this. No vias at all, just raw dogging it. The other one goes to this via and jumps over there. So in the future, I will be able to pick up on the other one. How do do you highlight the whole trace? Show. It's show is the command. Here to there, I could run like one of the magnet wires, but the other one would be just doot to doot. Because yeah, that only runs to there. And then this one, actually we can go out to this via. Oh no, but that's on the other side of the, oh no, the vias are on both sides of the board, you idiot. So we'll cut this one here, and then we'll cut this one here, and then this goes to that, and then this via goes to that wire right there. And then I'll drop a connector on top of it, crushing it dead. Okay, cool. So it's this one here we need to cut, and then we flip over to the other side. And I don't need any lead out from this, just because we'll solder it directly. There's no, like, this goes to there. Wait a minute. Wait just a minute. Oh, but we're picking up on, because this one goes out and around, so that one is in the vicinity of this one. So that's where we will get to it. But for the underside of the board, we are simply just cutting this off. So let's cut this over here. I can't maneuver this thing properly to get my angles correct. And now that connector is going to be in the way. All right, try that. No, that's not right. It's not right. It's unethical. No, wait, no, that's not what I mean. The massive steel plate is kind of unwieldy on the table. All right, this is a much better angle. So just cut, cut, cut. Get out of here. Remember, I'm viewing this in the exact same way you guys are seeing it. I'm just as blind as you are. So from the via to that pin, so from here to here, nothing. Make sure I have severed the trace. So now we don't need to do anything else with this area right here. Trying to desolder a heatsink. That sounds as frustrating as when we tried to do that. It is not a fun thing to do. Okay, so now I have this one running through these. Where are we? What are we? We're down here. So this one right here. So that needs to go to this to here. No, that's what we cut. We just cut that. So this goes to here. And how do we run the other one? The other one is on this going shoo-doo-doo-woo. So this one's here. It's actually here to here. So we got to go from here to here. And then we have to go from here to here. So we're going to do a nice big cut in this one. And we'll expose both sides of it. And then that'll be our thing. That'll be our thing between us. Just me and you. Don't tell nobody. All right, hold on. Yeah. Okay, so there goes that trace. I'm going to give it a little bit more space. With this size of trace, it's not very deep. There. So that should be a nice wide area. And I gotta be careful about where I'm exposing ground on this. Because that via right there is gonna kind of threaten us. Yeah, it looks like I gotta let's get away from this via, because this via is like, what just happened? My clamps just gave up. Ah! The clamps unclamped and the whole thing like moved. Okay, there. Stay still. There we go. All right, so that, but we're not going to solder there. We're going to solder over here. It's like I don't know where the contact of the knife is. And if I harass the ground, we run the risk of soldering the ground. And I just did it. Damn. So we got to be really careful about where that wire is making contact. Let's see if we can tin that area. I mean, I guess I could just run the wire all the way down to here. Maybe that's the play, instead of waffling around with potentially grounding our circuit. Let's just see what happens. Yeah, okay. Totally uncooperative. Actually, that's pretty good. And then, what was the other one? This is cut off, and we're going from this one to this one. So that needs a little bit of love. A little bit of love. Working in the valley of the connectors is kind of annoying. Yeah. Well, maybe I should expose it way over here where we're safe from all of this stuff. Yeah. This is what you got to do when you design a PCB. I mean, it's not cheap to get them printed, so you got to make sure any mistakes that you've made, you correct before moving on. So that's where we are, correcting. Heating it up right now, yours seems more fun. Preheating is going to be your friend, yeah. I'm channeling my inner Louis Rossman and hissing at your scratching with the tweezers. That's a knife. I scratched with a knife. That's a full-ass knife that I scratched with, because we need copper to be exposed as our solder pad to bring us over to here. We are making our corrections. I am preaching, practicing what preaching practice, and the preachers practicing the preach to the, wait, no, that doesn't make sense. Teaching respect. I teach you to respect me. About to burn myself with a soldering iron. Trying to wipe the end of a wire that I can't even see with solder. Solder. This needs to be flat. I don't think it's flat. I need to flatten it with something like the end of the iron, but I need to make sure that I'm not hitting this connector and melting it. I think I have already in a couple places. So I can't, everything is on a scale that's sort of smaller than what I'm used to. I just feel like the iron's not hot, but I am moving that solder around. What I should do is insert it from below and then move it over. That's probably what better task. Yeah, hold on. Let's do that. I'm gonna clean the iron off and then I'm gonna go in from below. No, no, no. It's harder to do than you think. Do it where I can see the end of the wire. I move up, yes, yes, yes. Yeah, I didn't expect that to work. I did not expect that to work. Just hold that there and let that fall. Okay, now that should be locked in, and I can take the end of it, bend it into position. Bend it into position. Good God, where's my pin tool? Maybe the knife. Scalpel, scalpel. Do you concur? I do not think solder is sticking to the end of the wire. I think I need a big puddle of solder. Hold on. A big puddle of solder. Could also be this iron messing with me again. If I twist it around like that, that might do it. Okay, so that should probably solder a little more easily. You guys can see why I was reluctant to do this. It's very, very difficult. Yep, that's on. Okay. Which one sounds like a band name? There's our wire repair. And then I'm just gonna clip that. And we'll do the other one. Okay. Puddle of solder. We're a puddle of solder. Crawling in my skin. Okay, let's not do that. Don't do that. Ad break. That was surprising, sudden, expected maybe. I don't know. I wasn't looking at the timer. I would have let it cut me off if that were that would have been funnier. We're almost there. We just need to do this connection from here to here, and then we run it. We run it and we see if it tests okay, and then I can plug audio into it and we can see if that's okay, and then I'm probably just gonna do the correction in CAD and then run another set of, I can't see where are we? There we are. Do another set of boards. Okay, so I need to do the solder on the end of this wire so I can get to that trace. I think mostly the way that this enamel wire actually ends up making a connection is at the very end of the break in the wire is where I'm able to get solder to like really stick. I think that's what's happened on both instances. But I'm trying the method where I'm just scraping the end of the enamel with the soldering iron, and that should be enough to mechanically separate it, but it's very hard for me to even just like see what I'm doing on this because this wire is just invisible. What time is it? Okay, we're getting on there. We're getting on. We got some time. I can get this to work. And then what we can work on tomorrow is building up some filter modules and figuring out how we're going to test those, tune them. All right, so that should be okay. I just kind of scrape it a little bit. And then I've got to work around all this crap. Look out, multimeter. How was I soldering this before with the multimeter in place? That's going to be a mystery. All right. Can I actually... I think I can go through the via. Is that the right one? I think so. I do not have any parallax. I cannot see through. I don't think that's working. God, the vias are long on this board. It's a thick board. Look at all the material that's gone through. Jeez. Okay, hold my breath. No, it's not big enough for this wire to fit through. We'll just have to go from surface to surface. All right, waiting on the green light. Welcome back, everybody. All you ad watchers, I appreciate you very much. Wish you didn't have to watch ads, but that's just what we're doing. That's how I'm getting discoverability, so that people can actually find my stream. Buy my book. Buy my book. Ooh, Jess, bother rather. Don't use your real name. Nobody's gonna get your stupid boober memes. The old millennials will clap like seals when they hear you reference the critic. Hey, I think what's going on. Okay, I need to get some solder on this. Why would you use large traces on your design when microscopic traces make it so easy to route everybody? Everybody's happy. Traces have miles and miles to play with. Yeah, it makes troubleshooting so... what's going on here? Troubleshooting so much easier. All right, got a little solder on there. You got a little bend in the end of this. Oh, no more. It went away. I can come from up here. Yeah, there we go. Oh my God. Okay, it's all over the place. It's all over the place. I need to stabilize it with my fingies. There we go. Where are we? Like this. No, I need the wire to be stable and lying down on that trace in order to get this to work at all. Okay, now for the hat trick. Now I'm not really putting a lot of pressure down on this when I cut this, so I'm literally just lying this down on it. Oh, whoa, 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 whoa. Whoa, 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 whoa. No, 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 no. No, 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 no. Careful, careful, careful. Okay. Because I have no feel because this wire just doesn't exist. It's so small, it's just not there. Nope. Maybe lay it down from over here. I think this will do. Yeah, that'll do it. Now that goes all the way to the via, right? It does, okay. Need that to just hang out right there. And then by the grace of a higher power, maybe this will actually make a connection and solder to the end of the enamel wire. Or it just will ball up on itself. Yeah, that's cool. Fine. We're cool with that, I guess. Sorta, not really. I don't know if that's actually soldered in. It kind of looks like it, and I guess I'll put the multimeter to it. If I can poke it with the tweezers and it doesn't move. It moved. Okay, it's not. Hey, what's up, Weasel? The screen names. The screen names people choose for themselves. I'm like, hey, fucko, and it's like not me. It's not me, it's actually the name that I'm referring to. Finally catching a live stream. You should check the schematic for Mutable Instruments links, which has a buffered MULT and bicolor LED circuit. Is there one specifically? It's a buffered MULT and bicolor? Because which one is that? That's not, yeah, mutables, because I brought all my sources to the table at the beginning of this stream. So I've cited all of my references. And for the most part, for what we've built, it seems like it works pretty well. But I've been, for the most part, copying mutable designs because they're really, really good. Oh, that might be attached. That actually might be attached. Let's check. Weave. Oh, wave to mom. No. There was a Djibouti show fan that watched my streams early on, and the name was Big Wave, and they started streaming, and I would promote them, but I'd always call them Big Weave. I'm like, damn, look at that hair. That's a big weave. We need a new one because it cut the ground pin off of the one. Specifically precision buffered MULT. Oh, plus some others like an adder and a summer. I started my journey with modular instruments by repairing Julian's kinks over and over. It was like multiple times that I repaired that damn thing. And I'm very familiar with the schematic of kinks. I probably should have started with kinks, huh? Where did the front panel go? Front panel. Those tantalums really should not have exploded, huh? I can't believe we blew up a bunch of tantalum capacitors today. They should not have exploded. Shouldn't have. Where did the front panel go? All right, I'm looking around. Hold on. This is not an ideal test setup. I'm showing Mom your stream. Okay. Let's see here. Front panel, a gray piece of plastic with a bunch of little holes in it that are spaced out just right for me to put this thing together and not have this thing fall out. It didn't fall to the floor, I would have heard it. This is a good argument for constantly cleaning up your test setup. It helps to have a clean test setup. It helps you not be totally and completely disorganized or blindsided by missing parts. I don't get it. Where did it was here. There's not many places for things to go. Put the knife away before I hurt myself. You're gonna hurt yourself, bother. Put the knife away. Put it down. Oh, it is on the floor. Hold on. Clean is relative. This is what every surface in this shop looks like. It's not a good look. Put your mama on the phone. That's a line from Saul Williams and Trent Reznor. Because my memory is so weird, references are constantly popping up in it. Which is the new one? There are the LEDs. Okay, so it's, I want to screw in the Thonky Cons that are next to the one that I'm soldering in. Okay, there's that. Now we do a little bit of this. And the only adjustment, oh wow, that's, yeah, these are loose now because we've been using them. When I say something, you say nothing. Something. All right, doink. And then that is a bad song to have stuck in your head. Okay, solder over here. I guess we'll just load it up with a big solder because the act of soldering these should connect our remaining connections, and then I can ohm them out and see whether or not we succeeded. And if we didn't, tough cookies. There's nothing we can do about it. So we cry. technically that should connect, although that via shouldn't. Let's just bend you out of the way there, bud. Okay. So now if I plug in the plugs, this one, and then this one, we should have cut off both of those switches so that we only get connections to our specific banks of things. So what I can do is I can get the multimeter back over here, the multimeter. We got to emphasize all the wrong syllables so that we poison AI. Okay, so from here, and again, I'm using the CAD design to figure out what I'm supposed to be doing here. We should get a connection from, well, actually, if I do no plug in the second one, then the banks on the ICs, which will be, where's the IC? It's right here. And then our signal comes in on one. Yeah, I wonder what accent Bother has. These ones, these two pins. So 1, 2, 3 from the bottom. So if I do the end of this one, and then where's my other probe? And then it should be going to both banks, so it would be 1, 2, 3. We get nothing. Good day to you, sir. Make sure I got a good connection here. Try this one. 1, 2, 3. 1, 2, 3. Well, there we've got an ohm. So one of these is not connected properly, and it's this connector here. Yeah, so that's not connected. All right, so which one is that? There's not much we can do if the other one's bad. I probably should have checked that one before soldering the connector in. Everybody's bathed in flux, but I think that connector is not making good connection. So let's wrap that around a little bit. Just give it a lot of heat so that maybe the enamel wire will expose itself a little bit. You have to mispronounce it to really poison the AI. I think I probably am already AI poison. To break speech to text, I mean, I'm from Philly, I could probably manage that. If I go into a Delco accent, is it gonna like completely poison AI forever? There we go, ohms, that was the problem. Look at that, Father done good. So now if I unplug this, geez, this is not conductive to, ow! Gee, God, it's fighting me. Stop, fucking thing bit me. Okay. Where'd my probe go? Okay, there it is. Jeez. There. And then 1, 2, 3. That one's good. That means 1, 2, 1, 2, 3. That one should be good anyway. Wait, 1, 2, 3. Uh-oh. No, 1, 2, 3. There we go, ohms. Okay, and then if I plug both of them in, this one goes to this bank. Not this one. And this one, this is, by the way, this is how it should have worked all the time. I made a mistake in the schematic. Okay, so now, theoretically, once I make the correction in the circuit and spend another $60 and wait another month for all the stuff to come in the mail, I'm very disappointed with myself about this. I can't believe that that was the one mistake that I made. I wired up a normalizing circuit and didn't realize that the normalizing circuit was wrong by virtue of not having the correct stuff, the correct part of the correct stuff, so that now, or well, when I build one of these PCBs without all those little corrective wires, the banks, the input for the one bank goes to the wrong side of the circuit. It's flipped. So if I put the scope back on and I turn this on, we have a sine wave pumping into this, and you can see they both kind of look sine wavy. All of the LEDs are on, which means that wherever I plug into the outputs, I get a nice clean sine wave. But if I plug in, for instance, a 2-volt DC, only the green LED is on, 2-volt DC on this bank, sine wave on this bank. It would have been as easy as that. And then we could have done a little analysis to see if we were actually pumping this up a little too much. I don't think there's any amplification going on. It looks pretty good. But I could have given it to Julian. But instead, I had to do several bodge wire fixes in order to get this thing to... That's actually pretty bright for 2 volts DC. 2 volts is pretty... maybe I need to do something with the range there. I can also do... That might be noise. Yeah, there's a little noisy. That's what the glitching in the LEDs are. That's funny. That's going, but this isn't showing anything? Why would that be? Hey. No, 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 no. No, 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 no. Hey. Don't touch me. Why no output? Oh, because it's out of range. We can't see it. There you go. And sometimes it's clean, sometimes it blows up. It's like some error with the I2S going on this. There we go. So the LEDs are doing their thing. Yeah, that looks pretty good. All right, so in terms of like the regular function of this, I'm okay with it. I may want to expand my testing a little bit and see how it does it with like higher frequencies and stuff. But for a powered MULT, I mean, I'm willing to call that. I just need to put this on something else. we need to reprint this. I wonder if I should go through JLC PCB. The signal looks clean from my perspective. Sometimes it's clean, sometimes it blows up. It's very relatable indeed. Yeah, so we're good, I think. That's a very smooth low sine wave. It's yeah, the I2S stuff is very, very good at producing stuff like signals and audio and stuff. These are good. Like these I'm going to use in my module testing module. The module testing module is over there, and it's going to be 3 layers of wire wrapped signals and a vacuum fluorescent display. And I'm hoping that I can make it calibrate itself. It'll be able to switch its inputs and outputs around to voltage sources that it'll calibrate off of. And then I'll be able to have sort of a setup like this, but it'll be a little bit more versatile in its testing. Like I could, for instance, output a signal and then bring it back in and analyze it, maybe. But that's a lot of programming to go through still. How do these look? Smooth. This is actually a triangle wave. Nothing. Oh, nothing. Huh? Nothing. 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 Why do you not work? Is it one of your resisties? Is it the board? There's not a lot to you, circuit. Yeah, something is... Okay, so let's check what's going on with that jack. Let's check all the other ones. Sine wave. Sine wave. Inverted. No, it's still sine wave. Okay. All right, let's take a look at that one then. Doink. Doink. I am livid. I cannot believe that I made that mistake. I cannot believe that I made that mistake. There's always going to be some boneheaded mistake on a board design, but for it to be that. So the second, the lower one, 3, 2, 1, number 1, that one's not working. So 3, 2, 1. Why would you not work? You are associated with this circuit right here, I believe. Unless, yeah, because that's input. So it's input is here, and then this is the one that's not working. That one is coming in through there and going directly to those, and then it goes, it doesn't do the LEDs. The LEDs are working fine, and those go over to here, and we have, yep, that pin right there is the reason why. I was suspicious of you. It looks like it's not connecting. It's too far above the board. Too above board. These are very simple circuits. It's just I was supposed to implement them very cleanly. That was wow, that was a lot of solder all of a sudden. Well, now it looks nice and smooth and connected, so that's what you got to look for, is these little gaps between things. And since we have pins underneath these ICs, it's pushing the IC upwards. So that was just a little bit too far. So now we can see if it's not too far enough. Stripe. Stripe. Oh God, zebra. I just reminded myself of zebra stripe gum, which I think is a government experiment. Oh, see, I'm getting a little feedback noise. Look at that, 60 hertz noise. Okay, so sine wave, nothing. Sine wave, nothing. Okay, wait. Nothing. Oh, because this isn't... There, sine wave. Ooh, that was a little weird at first. I think that's just the act of plugging it in, I think, did something. Sine wave, and then these should be sine wave, sine wave, sine wave. I was thinking for like a redesign, if I did a front panel that was a PCB, I could connect the input to the outputs with like a line, but the line would, instead of being like a copper trace, there would be no copper there on that line, and then I would put LEDs in each of these 3 gaps and maybe a piece of tape over top of it. So you'd plug the input in, and then you would see an illuminated line that would connect you to the other ones. But I guess I'm not going to do that. I just have the top of the bank have a little indicator of what's going on. So when you plug into one and not the other, you get that signal on all of the outputs of your MULT. And if you plug in a different signal, that'll go in to the bank that it's adjacent to. But this mistake is so prolific and fundamental to the operation of this, and it's so hard to correct, that I'm going to have to do another board of boards. Board of runs. Board run of boards. And there's no bleeding of the channels, and it appears to be able to keep up whatever the amplitude of the signal is. If I give it plus minus 10 volts, it's able to keep up with that really nicely. What's the overshoot like? Oh, well, it stopped working because it needs my aura near it to function properly. Come on. Come on, I gotta pause the scope so that I can actually see what this... Oh, you gotta touch it. So we're doing a trigger. Oh, we got to go faster for the trigger. Oh, whoops, that's not faster. That's too slow. Okay, we're looking for a single trigger. What? Oh, wrong channel. Trigger menu, channel 1. Hello? Oh, yeah, channel 1, there we go. Channel 1, get out of my face. And there's our single trigger. And so what's happening in the milliseconds of lead up and down, it looks like our waveform is doing its little oscillating stuff. So it goes all the way up to the cutoff voltage in the milliseconds that it's transferring. And so we do have a little bit of waviness in this transfer from low to high. The signal coming out of my generator, let's take a look at that and compare. So I'm going to plug into my high-low. I need to run it just to make sure that it's actually working, which it's not until I do this. And then I'll hit it with a single trigger. Bada bing. Okay, so actually, let's store that. We're going to store that. How do I do that again? Let's see, waveform. I need to like capture the waveform. So I need to do measure. No, that's not the right one. Analyze. No, DVM. Yeah, some of these, oh, there's a digital voltmeter. Oh man, that's nice. I gotta learn all the features of this stuff. Reference, there we go, reference. And we're gonna do ref 1, and we'll save that to the reference. Sources channel 1, saved it to reference, run the scope again. You see that light, the light red line is our reference. And so if we go to one of our Johns there, and I plug this into the John, and we make sure it works. Boom, boom. Oh, look at that. You can see it overlay on that. So if I do a single trigger, look at that. I do wish the reference was a little brighter though. Ref 1, channel 1, no voltage offset, 5 volt scale, color, orange, light blue. Maybe a little darker. Or no, not orange though. Green. There we go. That should be easy enough to see. Let's offset the voltage just a little bit. Just so we can display the two next to each other. Okay, there we go. So look at this. Look at that. Holy. Hi, I am back from school. I don't care that much, but thank you. You can just say you're back. It doesn't, I don't know. It doesn't matter. I'm glad you're here if you got something to say. Look at this. Oh no, that's the wrong view. Just look at that. Look at that. So what we did is we captured the signal that my tester made. Oh, you're back from hell, parentheses school. Oh, you actually did have something to say. Oh, I'm so sorry. I read that wrong. I thought you were just telling me you were back from school, but you're back from school, which is also hell, and that actually is a fine thing to say in my chat. I appreciate that. I'm sorry. I've been clowning around with these circuits, and we got a lot of stuff wrong in this. There's like a big fundamental error with what I put together. Look at this. What I did is I assumed that J1 was the upper bank and J5 was the lower bank, and that U3, I don't know why it's 3, it should be 1, but that should be U1, and it's the first bank, and then this one's the second bank of outputs, right? So the circuit logically would go, this plug goes to the first one, and this one goes to the second one, and you can see already that I did it wrong. I reversed them. These should be the lower ones, these should be the upper ones, and I just took that all the way to the end of the design. I didn't do nothing correct. It just propagated through the entire design until we had a physical circuit in our hands. So we used some enamel motor wire to rip up traces and reverse the connection of these pins. It's a chef's hat. It's a hat for a chef. It's the poofy hat that a chef wears. I don't know what you guys are talking about. You guys have it wrong. The host doesn't care about you. Listen, Sark has an entire cutaway gag where it does an entire Disney I don't care thing. And it's so mean. Just watch egoistically. Okay, okay. You're not all that. You're not all that, chat. You're not all that. Even though I beg for you guys to be in this channel. So yeah, anyway, so I made a big doo-doo. And so we repaired it with micro wire. And then we took a look at these signals up close once we made the repair and everything. So our TL074 op-amp circuit, when we get down to the nitty-gritty, is so responsive that it is almost perfectly replicating the weirdness of the I2S signal square wave, going from -10 to +10 volts. Look at that. It replicates it perfectly. This is a voltage offset just so that we can see what's going on. But one of them is a reference that I captured directly from this plug, and the other's a reference that I captured from this plug. So that's pretty cool. I think that's pretty cool. It's also interesting that the I2S audio goes, and then it changes voltage level, and it goes, oh, and then it settles in. This is a control system. If you give an input change, there is an error in your offset that'll cause a proportional change, and then an integral change damps that proportion, and a derivative damps it even further so that you get it to settle in on a position. What about a more complicated signal? I don't have one. I don't have one. I don't have one. I've got to put my synthesizer back together to do that. I'm not totally certain if I want to wait to do that or not. Red light, green light, 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 red light. Okay, I'm entertained. I'm entertained by this. So, all right, conclusions from today. I fucked up. Sorry about the cursing. I screwed up. So we got to probably correct that in CAD. These were expensive. They turned out to be pretty expensive because on a day-to-day, tariffs are anything. It's very annoying. Should I design this with big capacitors? This is doing pretty good. If we're going from negative to +10 volts, I don't have 3 devices plugged in, but if we're going from negative to +10 volts and this thing is still able to keep up, I don't know if I need to have that extra current in big capacitors on this thing. It's not your fault, even if it is. It is absolutely my fault. The blowing up capacitors was not my fault. The blowing up capacitors was not my fault because those tantalums said they were 35 volts and it seems like they're not. I had those completely plugged in properly. Have a fart. Thanks. You guys always know how to make me feel better. Yeah, so making this correction, you know, I'll do this in software, but let's just put a note down right now. So on the documentation layer, put down text that says, flip these, you wing nut. Make it nice and big. And then smaller, or no, oops. Document, and these should be not tant. Just put that right there. There we go. So we need electrolytic capacitors, not tantalums. And then I need to flip these because I'm a wing nut. I don't know if the tantalums are going to be able to work out, though, because wider caps in that area is kind of tough. Because we've got a lot of signals to route. It looks like we can push them north a little bit, or sorry, to the left a little bit. Yeah, we could push those over a little bit, and maybe that'll allow us to do electrolytics. And on this, if I wanted to do that correction, I would just simply scrape up the ground plane a little bit. As, you know, towards the back of these, I could scrape up the back a little bit more, and then the electrolytics would fit there. It was nice when it was nice and flat, though, and the tantalums looked good. They were flat and chip-like, but unfortunately, can't win them all. The tantalum capacitors, they're very sensitive and they're very expensive. They're expensive. Like here, let's take a look quickly. Go to DigiKey. I could be wrong about this. Let's just look at DigiKey. I've got all this stuff in the way. Tomorrow we're going to work on regular modules that I didn't design. So we're looking for, not really, it's components, I think they call them, right? No. Electromechanical, hardware fastener, integrated networking, passives, I guess, capacitors. They put diodes under passives, which isn't really. And then we're looking for capacitor. We're looking for not a kit, we're looking for tantalum, which I think are just right here, right? Yeah, tantalum polymer. What are those other ones? Wait a minute, what's the other one there? Oh, just regular tantalum. We don't need polymer. Oh, get the scope. Dink. Okay. In stock, normally stocking. And then we're going to look for the voltage rating of somewhere over 30 volts. So 12 volts. Oh, but it's only a 12 volt system, so you're never going to see anything above 15 volts. Well, it's plus minus 12 volts. That's 24 volts. So we need something above 24 volts. 25 volts is above 24 volts. Yeah, by 1 volt. That's not enough. You want to get a little bit of wiggle room with your capacitors because the real world is messy. So we're actually going to go from 30 to infinity, I guess, whatever, it doesn't matter. Although that's gonna muddy up our results. So let's go from 30, 35, 36. Apply. Did I just apply something I didn't want? And that's gonna, now we have only 25 capacitors to choose from. Those are almost $1. That's 60 cents. 69, nice, 69 cents. 72 cents. These guys are tants? I guess so. So while it may be cool to use a bunch of like square, awesome looking capacitors, throwing a bunch of tantalums in your design is a bad idea, especially if you're trying to make something with TLO74s. It doesn't need an expensive capacitor. You still have the black background. I don't know why this loaded in like this. I guess I just didn't enable dark mode. Yeah, see, there's the black background. That's much more pleasing. Oh, I hear yappy dogs outside. All right, I'm gonna be back tomorrow. I should do the end card. I always do the end card. Let me just do the end card real quick. By the way, in stream projects section, I have all of the sources of why I made the decisions I made. Why I'm using this circuit and the values are because of stumbling upon several sources and using those sources directly. So we got the values eventually, and sort of I figured out what my path to absolution was on this circuit. I don't need to have that third resistor in here, but I'm leaving it here because, I don't know, maybe I could do something with it one day. I don't know, unless I want to make like an attenuator, then I could make something that lowers the voltage of the signals coming in and makes them appropriate for something else. But for right now, I think I'm good with the way the powered mult is. I am going to have to make a correction on the circuit that I don't think is going to be easy for me to undo. It seems as though I can't really get to the things that I want to get to in their locations, whereas making a correction in CAD is going to be dead simple. I just move this trace up to here, and then this one just goes all the way up to here, and then this one goes away. You know, that's it. That's all I have to do. Maybe tomorrow we can make those corrections real quick, and then this will be ready to order a different version of the board. And when I can eat $75 or less than that, but still it was around that, then I'll make another board order. Or I'll go through JLC PCB. Maybe that's a better thing to do. Thank you for the interesting stream. Cool to watch you troubleshoot and solve. That's the whole purpose. That's, you know, show you guys how this stuff can be fun little puzzles. But we're gonna get to this stuff, all this stuff when we come back, because now I've got a pile of parts sitting behind me, so we can make all the make all the corrections in CAD, and then we can move to other projects. Because this was, I don't have a scope on this one. This is really cool to see. It's just our TL074s are responsive enough to keep up with whatever this digital thing is doing, and even the noise it's creating, we are recreating. So I'm pretty happy about that. This is it's not a high frequency, but this is a very small time delineation, and so giving it music and stuff like that is probably going to be just fine. So the powered mult is almost done. We have one last push. I don't even know if I'm going to like save the parts of this one, because it's just resistors and a TL074. This one I could actually put into work. I could actually do stuff with this one. Yeah, might as well. All right, so not done yet, but we're close. Here is the end card. The end card with all of the end cardingtons on it, and it's ending with a card. There it is. Look at its cardliness. Hey, thank you guys for joining me. I mean, we got a bump in viewers in the middle. It's tapering down now as people have to like come home from school and stuff like that. So I assume everybody has lives, but we will be back on Saturday for all of those of you that can actually be well. Oh yeah, I'm sorry, unethical. We gotta end at some point. My butt hurts from sitting in this stool. We did a lot of good work today, and so this powered mult will eventually work. It's supposed to be like brick, simple, stupid stuff, but I screwed up. I got my stuff twisted, and so that is added to the list of checks that we do before we order a board. That's what these mistakes are for. I mean, there were mistakes on like all of the boards that I've made lately. This is another board that I made for stream, and 2 of the pins I decided to like flip them because something about the amplifier circuit was wrong. I went into a plus or a minus wrong. Got to watch out for this stuff, but as we use this stuff and as we build these boards and as we test them, we start to build up a list of things that we want to watch out for and internalize them so that we check them every time, and you know, you get better and better at it until you can be like me and never make a mistake. I'll catch you guys later.